Hello, good morning, sir.
Good morning, ma'am.
Sir, the session will start at 9:45, sir. The participants will come, sir.
Okay, no problem.
Just meeting ID password. Login number. Hello. Hello. Good morning, everyone.
మేడం
Sir, start చేయండి సార్. చెప్పండి సార్.
కానీ మా సార్ ఉన్నారా లైన్ లో?
ఉన్నారు సార్. స్క్రీన్ పైన ఉన్నారు. మీరు చెప్పండి సార్.
ఓకే ఓకే కానీ 1 minute ఉంది కదమ్మా.
మీరు చెప్పండి సార్. ఉన్నారు పార్టిసిపెంట్స్.
ఓకే హలో హలో గుడ్ మార్నింగ్ టు వన్ అండ్ ఆల్ participants. Good morning, sir. Dr. Vijay Kumar Della, sir. Very good morning to you, sir.
Yeah, good morning, sir.
So once again, on behalf of Department of Mechanical Engineering, Narayana Engineering College, Nellore, warm welcome to Dr. Vijay Kumar Della, sir. Today's morning session, resource person, subject expert, and also welcome to all participants for today's sessions. Really, I am very happy to say that with your cooperation of Dr. Vijay Kumar Della, sir, yesterday we have completed 2 sessions. One is on kinematics, robotic kinematics, and inverse kinematics.
సార్ మీ ఫేస్ కనిపించలేదు సార్, ఒక్క నిమిషం బ్యాక్. ఓకే సార్.
Today, sir also will continue the topic robotic dynamics from 9:45 to 11:15 a.m. After that, today's second section, modeling and simulation, that will be taken by Dr. V. Veerana, sir. And in afternoon section from 2 to 3:30, industrial expert ST Parvez Hussain Garu, technical manager II Club Hyderabad, will cover components, robotic components and assembly and demo sessions in our robotics lab. I hope that the participants will also gain some value added knowledge in robotic dynamics, modeling and simulation, some part of programming part, and afternoon you can gain some knowledge on live projects which already designed and developed by our robotics team. Once again, thank you one and all on behalf of Narayana Engineering College, Nellore. Thank you, sir. Dr. Vijay Kumar Della, sir. You can start your lecture, sir. Thank you, sir.
Yeah.
Thank you.
Yeah, thank you very much, sir, once again for your nice briefing about me and sessions, yesterday's sessions. As I have covered 2 sessions yesterday, one on robot kinematics and the second on inverse kinematics. Now today I will deliver a lecture on robot dynamics. Okay. Yeah. So dynamics of manipulator. Once again, manipulator is the mechanical structure of the robot. Kinematics deals with the relation between position and orientation of the end effector and the joint variable of the manipulator without considering the mass of the links or the forces torques acting on the manipulator. So it is a and effector. You know what is the and effector? The the something which is attached with the wrist of the manipulator is known as the end effector, and the end effector
Uh,
either may be gripper
sir,
or tool.
sir,
Yeah, yeah.
sir, is there any possibility to provide the presentation, sir, if possible? I mean
Uh,
the screen sharing.
oh, sorry.
It's okay, sir. It's okay.
Okay, okay, okay. Yeah, is it visible, son?
Yes, sir. Please.
Yeah, yeah. So dynamics of manipulator. Manipulator is the mechanical structure of the robot. In the kinematics, we deal about only motions of the robot without considering the mass of the links or the forces torques acting on the manipulator. Okay, and end effector, the something which is attached with the wrist of the manipulator. Here, joint variable. Why we are saying joint variable? Because joint may be either prismatic or revolute. That's why we are not saying here joint angles, because joint angles named in the case of rotary or revolute kind of motions, joints. But in the case of a prismatic joint, the joint variable is the joint offset, O double F S E T, offset of the manipulator. Okay, and as I told, in the case of linear motion, there will be force as output, and for the angular motion, the torque will be uh, as the input. Sorry, as the inputs, forces, torques as the input to the joints. Okay, and dynamics which deals with the relation between position, velocity, and the acceleration of the robot's joints, along with the force torque exerted at each joint to cause the motion. Okay, so in which both are considered, either the kinematics, okay, kinematics motion, and uh, the forces torques also. Now, this is an outline for this dynamic portion. So, firstly, introduction part we will cover, then language equation. In the language equations, 1 degree of freedom, 2 degree of freedom spring mass system, and 1 degree of freedom concentrated mass system. Means suppose we consider uh, a link which mass is concentrated at the joint, means at the end, and the same for the 2 degree of freedom. Then the 1 degree of freedom robotic manipulator, then 2 degree of freedom robotic manipulator, and also uh, Newton Euler, that was regarding Lagrange Euler approach, and but also Newton Euler approach we can add, and the bond graph technique. It is a graphical way of representation of the dynamic system, and not only dynamic system, others also like electrical, hydraulic, magnetics, all we can model with the help of this bond graph technique. Okay, so these are the approaches, different approaches to derive the dynamic equations of the manipulator. So once again, Newton-Euler approach. Second one, the Lagrange-Euler approach, and the third one, the bond graph technique. This I used in my research. Okay, so Newton-Euler approach is based on a force momentum equation, and this is the Lagrange-Euler approach is based on the energy criteria. So energy balancing equation, and this is the force balance equation. Bond graph technique is the graphical representation of the system. Okay. So coming back now, why it is required to study? So robot arm dynamics deals with the mathematical formulation of robot arm motion equations. Yeah, it's okay. Like we want to know about how much forces or torques required to move the manipulator to actuate the joint so that the robot can get the desired motions, or in another way, the robot can go to the desired location and can execute the desired task. Okay. And it provides an insight into the structure of the robot system. Means uh, we know about structures, about like weight of the manipulator, regarding payload of the uh, object, and regarding others like um, sensors, actuators, weight of both. We can know about this. And dynamic is a basis for model-based control system. So with considering the dynamics, then only we can control a robot. Without considering dynamics, we cannot control a robot properly. And also a platform for computer simulations. Okay, so with including considering dynamics, we can simulate the model accurately. Suppose uh, why we are studying dynamics? Suppose I am handling this object, okay, or handling. So I am feeling some weight here, okay. And suppose we neglect the weight and uh, I move it, means my robot manipulator moves it, okay, without considering the weight of the object. So it is okay, yeah, almost negligible weight, but suppose heavy load. So definitely to counter that, more forces or torques are required. Okay, so that's why we need to study dynamics of manipulator. Then only we can control a robot. Or without considering this dynamics of manipulator, the actual behavior of the manipulator will be different. And if you perform, why we study this modeling simulation? Because before the performing experimentation, we want to know the, we want to simulate the means we want to know the behavior of the system, and that should be not far uh, means mm, different. That should not be more different between the experimentations and the simulations. Okay, that's why we need to consider all the parameters which are required in the real work, real experimentations, like frictions, like environments. Okay, so so dynamics of manipulator, it is a platform. Hence, it is platform for computer simulations. And this I have already covered the three approaches. Okay, mainly, but mainly two approaches we know. Okay, this is also good, but generally, if you won't found in uh, simple textbooks, but if you go for specific and if you do some research kind of work, also it is not required research, but it is also a very helpful tool, bond graph technique. However, it is not so popular. Yeah. So Newtonian and the Lagrangian approaches for dynamic modeling. So in Newtonian approach, vector-based method required to isolate each rigid body from the adjacent bodies. Okay, and the interaction forces and the moments at the joints are to be considered to obtain equation of motions. Okay. So with the Newtonian approach, you can see it is a manipulator, 2 degree of freedom manipulator, and see the torques applied at tau 1, tau 2, and here the joint variable is the rotary motion theta 1 and theta 2. So now we are going to analyze, means we want to know the force required to move the manipulator. Okay, so what we have to do, we have to separate, we have to isolate a body. See this, we remove the support here. Okay, then what are the reaction forces in x and the y direction? And similarly, if you decouple the joint, okay, then what about the torque? This means what about the resistance at the joint? Okay, so see this resistance. You can see here there will be forces and the torques at the joints. Okay, so in this way we can make a free body diagram of any system. Actually, dynamics is the some complex for UG students. That's why in most of the syllabus it is not covered. Mainly up to kinematics we cover, but dynamics, if you see very long equations, for even for this 2 degree of freedom, we will get if you start doing deriving equations, then 3-4 pages are required for this. So that's why it is not mainly covered in UG syllabus. Okay. So with this, now we can write equations and balance the equations. Uh, then a Lagrangian approach. It is based on energy approach. Kinetic and the potential energies are obtained in terms of kinematic quantities to define Lagrangian. Okay, and he is Joseph Louis Lagrange. He is the founder of this equation, and some examples like you can see it starts from A, B, and C, D, E, F. If you see A, so it is what a string mass card, string mass system, and here in the B there are two masses, and there are then uh, two springs. Okay, so similarly for the manipulators, 1 degree of freedom, 2 degree of freedom manipulator, here joints are concentrated, means at the joints, means the link mass of the link is assumed to be concentrated at the uh, end. But here in this case, we are considering the mass is distributed. Okay, and same 1 degree of freedom and a 2 degree of freedom robot. Okay, suppose we want to know uh, about the forces required. See, the forces required to uh, to move this object, this card. Okay, so there is a swing. It is attached with the swing, and this is like a wall, and it is the base is here. The ground, it is suppose uh, lying on the ground. Okay, x1 is a variable, means it can move linearly along the x-axis, and this f is obviously the time varying equation, and single degree of freedom is being because we have only one mass, one variable. Okay, one variable, that's why. So what we have to do now by this approach, if you focus this one, L is here the Lagrange, and also it is known as the Lagrange operator, and here this is you can denote it by K and P. Okay, here it is denoted by some another symbol, but you can write simply here kinematic equation just for understanding in the better way. Kinematic equation minus potential equation. Okay, so now how to get the kinematic equation? All you know the kinematic equations for this system. Okay, so it is 1 degree of freedom. That's why there will be only one step. So what will be this? 1 by 2 m1, then v1 square. Okay, so what is the x? X is what here? Variable. If you differentiate with respect to the time, then we will get the x1 dot here. X1 dot denotes the velocity. Okay, so in this way, we got the kinematic equation of the system. And similarly, we can get the potential energy equation. It is 1 by 2 k x square. Okay, and k is what? It is the spring constant. Okay, okay. Now what we have to do? L is here kinematic energy minus the potential energy. So kinetic energy we have taken from here, and potential energy here we have written. Okay. Now this is the main formulation of the Lagrange equation. And what is this? See here, there are two terms in the left side and the right side. It is whatever the external forces or torques. Okay. Here the external force is F1. F1 is the external force. Okay. So see what we are doing here. Firstly, two steps are here, and the differentiation, partial differentiation of this Lagrange operator with respect to the velocity. Partial differentiation of the Lagrange operator with respect to the velocity. Okay, and then again the time derivative equation of the resultant. Okay, and in the second step, here again we are doing partial differentiation, but remember not with the with respect to the velocity. Here with respect to the position. Here see simply x1 only. Here x1 means dot is not here, but here x dot is here. Okay, so x dot denotes velocity, but this only x denotes the position variable. Okay. Now what we have to do step by step. From the first term, we have taken this the partial differentiation of Lagrange operator with respect to the velocity. Okay, so see in this equation, the velocity term is here in the first step. Okay, not in the second step. It is written by mistake. There should be dot should not be there in the potential energy equation. Okay, so means what we have to do here, we have to do differentiation with respect to the velocity. Hence we are getting m1 x1 dot. Okay, now what we have to do, again we have to do this derivation with respect to the time. So x dot hence becomes a double dot. Okay, now if you focus on the second term, okay, so second term, what we are doing, partial, there is a partial differentiation of the Lagrange operator with respect to the position. Okay, so means this we have to differentiate with respect to the x1. Okay, so what we will get here, we will get here k1 and x1. Okay, okay, and by putting these both equations, these both derivatives in this equation. Okay, so we get
Excuse me.
finally, yeah.
Excuse me.
Yeah.
Your voice is breaking too much. Nothing is understandable what you are.
Okay. Okay, just one minute. Okay. Yeah. So here this is a 1 degree of freedom spring mass system. Now we want to know the dynamic equation for this system. Now, is it okay? Please let me know.
Some systems are okay, sir. Some systems are disturbance.
Yeah, don't know, sir, why.
I think net problem, sir. Net problem. Net problem.
Yeah. Hmm. Yeah, actually, we shifted in new building of NIT Jamshedpur. So in new building, there is a network problem, but not like that. Network problem means mobile we cannot connect, but net problem is not here. But why? I don't know why it is. Yeah, just 1 minute. Just 1 minute. Just 1 minute.
केला आज करेक्ट केलं आज त्यांनी करेक्ट केलं एक मेल टाकला होता
Okay, just 1 minute. Stop share now. Yeah. So what we were discussing, we wanted to know about the dynamic equation of the spring mass system. And with the help of this spring mass system, we can derive the dynamic equation, the force equation of the system. Okay. So regarding a Lagrange equation, this is the Lagrange equation. You can see this is the formulation of Lagrange equation, and it has two terms, the first term and the second term. The first term is the L is the Lagrange operator. Here you can see it is differentiation with the kinematic equation and the potential equation. And how to get the kinetic energy? So kinetic energy is here 1/2 m1 and velocity. So velocity is here x dot, okay, square. And similarly, potential energy. So what will be the potential energy? So 1/2 kx square. And the k is what here? K is the spring constant. Okay. Now, putting the expressions in this Lagrange operator, we get this one. Then what we have to do? We have to get the term of this. Means we have to differentiate with respect to the velocity. So we are differentiating the Lagrange operator with respect to the velocity, and hence we are getting, if we focus on this kinetic energy, so it becomes here m1 x1 dot. Okay. Now again we have to differentiate it with respect to the time, and then we will get the m1 x1 double dot, because it is a time differentiation. Okay. And similarly, now we have to differentiate the Lagrange operator with respect to the position. Okay. So if you see in this, so there is only the second part is carrying the position variable. Okay. So by doing that, we are getting k1 x1. Okay, and by putting all these in this Lagrange equation, so at the last we are getting this m1 x1 double dot plus k1 x1 is equal to f1. Okay, so in this way we have derived the dynamic equation for this system, and the system name is here single degree of freedom spring mass system. Okay, so this also we can do with the help of software. But before that, I want to come back to Robo Analyzer software. Yeah. So forward kinematics we have done, inverse kinematics we have done. Now we have to look at the inverse dynamics and the forward dynamics. So what is the inverse dynamics and the forward dynamics? So you can see the inverse dynamics easily we can get. One have to take a help from Google inverse dynamics. It is defined likewise forward kinematics and inverse kinematics. Inverse dynamics of a robot.
Excuse me, sir.
Yeah,
Sir, your screen isn't visible anymore, sir.
yeah.
Also, few other people are facing problem because of, I think so, the voice issues or something, sir.
Voice. So, shall we give?
Yes, sir. But you
Yeah.
have the network problems, I think.
So okay. Then just you need to wait. In between, I can say hello. Hello. Yeah, just 1 minute. 1 minute.
अडीच 3,000 पॅकेज आहे तुमच्यासारखी माणसं आहे ना रोज एक स्विच.
Yeah, please wait just 1 minute. So, Siddha sir, please, I have shared one link, test link. So please share among the participants. Then I'm just going to my quarter. I will be connected from there. Here, I don't know what is the issue, net issue. I'm at my department. Okay, so please just bear with me. I have shared one link for the test. In between the please appear for the test. Okay, sir?
Okay, sir.
Yeah. Shall I share to you this link?
Okay, sir.
Okay. But how to share? I have shared this to Siddha sir. Can I share? How to share? Okay. So the mail, can I share?
Okay, sir.
But which one mail?
Sridhar?
Yeah.
Sir. HOD, Sridhar sir mail, sir.
Okay.
Okay, sir.
Okay. I'm doing it. Just.
Sridhar? Sridhar?
Sir, within sir.
ఓకే అమ్మా వాయిస్ వినిపిస్తుందా చెక్ చేశాను ఓకే ఓకే థ్యాంక్ యూ
For the disturbances, so you can proceed, sir.
Ma'am, I have shared one link for the test. So please ask to the participants in between, they can appear.
Share that link.
Okay. And I'm going to my quarter, then I will be connected from there. here I don't know why, what is the problem. Okay, in between, I have shared it through mail.
Okay, okay, sir.
Hello.
Yeah, yes, sir.
Sir, actually, I am Padmakar Raut, but my login name on the screen is showing as Patil JK BVIT. Actually, I am Padmakar Raut from BVIT.
Okay.
So please correct it. Yesterday, I have sent the mail that Patil Madam, but still the name is as Patil JK BVIT. That should be a Padmakar Raut BVIT. Okay.
हाँ हो गया था हाँ नेट नहीं आ रहा है ना नहीं तो नहीं उतना भी इसमें नेट नहीं आ रहा है
Okay, sir. I will change, sir.
Yeah, why not to try once again? I'm getting disconnected, then again I will try. Yeah, please allow me to share my screen. Sir, ma'am, please allow me to share my screen. Yeah. And please let me know whether I am audible or not. Yeah, please let me
Is
know.
audible, sir?
Audible?
Yes, sir.
Okay. So we were talking about the forward dynamics and the inverse dynamics. Okay. So this I wanted to take before simulating. I wanted to take help from the. Okay. Yeah. See here with this block diagram, it includes the inverse kinematics, inverse dynamics, joint PID control. Okay. So here in the inverse dynamics, what are the inputs? So desired motions, joint motions are the inputs. But what are the outputs? The joint torques are the outputs. Okay. Now it might be visible. This robo analyzer software screenage might be visible.
Yes, sir, it is visible.
Yeah.
It is visible, sir.
Yeah. Now what we are going to do, forward kinematics we have done, but once again I'm playing this. Okay, then inverse kinematics. In inverse kinematics, these are the multiple solutions, and by clicking this IKIN, then I will get the solutions, values of all solutions. So here 8 solutions for this configuration, and it depends on number of solutions, it depends on the input values. Okay, so this we have done, and by suppose I want to show the solution 4. So see how the configuration is being changed. Okay, now this is done. Then I want to know about the inverse dynamics. Okay, some error, why some, okay, forward dynamics, then inverse dynamics. Okay, and in inverse dynamics, you can see what are the parameters like center of gravity, we are taking into consideration mass and the inertia. Okay, mass and the inertia of the links we are taking into consideration. Okay, and now how to get, means how to validate. So from the help of this graph, we can validate. If you see, suppose we are taking a joint 1, so joint velocity, acceleration, but we are talking about dynamics. So we are taking here this, we are clicking here, then see the values of forces in the, see it is force versus the time. Okay, in this way, in the same way, we can also get the forward kinematics and see by including the dynamics properties, how we are getting the trajectory, how we are getting the motion of the manipulator. So in this way, we can demonstrate. And there is another software. Okay, I want to open it from the starting. Okay.
Sir,
So,
sir, please
yeah,
let me know the name of this software, sir. Please.
Robo Analyzer. Robo Analyzer, and the another software, it is the symbols. The another software, symbols. Okay, so here already what I made a model also, but also we can open some new. Okay, now the string mass system we want to draw with the help of these symbols, and the technique name is bond graph technique. The technique name is bond graph technique. Software name is here symbols. And now what we are doing, we want to make a model of string mass system. Okay, so string mass system, so there will be one source of suppose there will be one source of force. Okay, so force we are going to take the parameters of force. Here in this language it is source of effort. Okay, source of effort, it may be either force, it may be either torque. Okay, and the spring mass system, so spring,
Sir,
the element is spring. Yeah,
sir, can you tell the software name once again? SIMBOLS.
yeah, it is written here, sir. Symbols.
It is not visible. Can you type it in the chat? No, that.
Yeah, symbols, symbolic symbol. SYM.
Sir, can you increase the font size?
Because if I search it in Google, I'm not getting it.
Sir, we can download it from internet. Is it available from free form source?
That I'm going to show you, sir. Going to show.
Okay, sir. Okay, sir.
So from here, just a bit. Yeah, is it visible? Please let me know.
Sir, slightly increase the font size.
Ma'am, it is male, so I think I cannot. But
Just press Control plus, sir. Control plus, it will get increased.
okay, Control plus. Oh, sorry. Yeah.
Thank you, sir.
Yeah. It is a open source software. Earlier it was commercial, but now open source. So with the help of this link, you can download it. I am doing it. Okay. Suppose I am clicking here. Then it is this link is this window is coming here. Then you can download from here. After downloading, where it is downloaded, I have downloaded it here. So see, you can see here, symbols will be here again. Control plus. So here the software will, the folder will come here, and from that folder, again what we have to do.
Yeah, enough, sir. Thank you, sir. You can go ahead with your original plan, sir.
Okay.
Thank
Sir,
you,
you are
sir. Thank
sending this link to us?
Yeah, this.
Okay.
So here, no need to install the software. Just unzip and copy the folders somewhere in your PC, wherever you like. Start using the software by opening the bond pad. This is the bond pad.
Okay.
Okay. It I kept. Okay, where I kept, I forgot. Here I kept it. Okay, and see here symbols. Symbol Shakti. Okay, and if I go in examples or beans. Okay, so see here the bond pad application. If you see the type, so here it is application, and now I'm clicking this. Okay. Okay, and more, you can make you the bond graph model and derive that system equations from this software. Okay, system equation you can derive. And what is the beauty of this software? You need to write only kinematic equations. Like I'm going to show kinematic equations. It is the physical model of the robot in the way of graphical way. Okay, like if it is a 6 degree of freedom robot. See, this is the base of the robot, and this is for link 1, link 2, all information it will have. Suppose for link 1, it is the sensors we have put. See, here sensors, okay, and then we are modeling the link. Suppose link 1 we have modeled here, and also we have considered the center of mass of the link, and the ends of the all links. So this is for link 1, velocity of link 1, position of link 1, and the position of means x direction and y direction. Okay. Similarly for link 2, similarly for link 3, link 4, link 5, link 6. And at the last, there will be the end effector positions. Okay. This here 653, 654, these are the end effector positions. Okay. Now, what about the controller? Here the controllers, PID controllers I have used, and a reference trajectory I have given to the robot team. Okay. So this part is SF here. SF is you can see here in the drawing tool SF element. So SF element is source of flow. Means here we have given the equation of reference velocity. Okay. So and this is the middle part is the Jacobian part. Okay. And what is the Jacobian? Jacobian converts the rotary motions into the linear motions. Like suppose we are going to handle any objects, so we are rotating our joints, then our hand is moving. Okay, hand is moving, suppose linearly, so there is a concept of Jacobian. So due to the Jacobian, the rotary motions are converted into the linear motions. Okay, and what I have told with the, if you draw these graphical models, okay, then we need to relate, like what is suppose theta 1. theta 1, where is the theta 1? It is theta 1. Okay. Theta 1 is here. So, and what about here? You can see theta 1. So, Q416. This Q416 is it denotes the theta 1. Okay. So, with the help, if you draw this model in the form of this graphical way, then in the equation expression window, we need to express all the terms as per our convenience. Okay. Also, we need to initialize, means initial configuration of the robot. So these are the only kinematic inputs. Okay. So with the help of these kinematic equations, see what we are doing due to some this part it is not initialized, but here we can download from here. We can download, sorry, we can derive the equations. And what are the derived equations? Already I have done before. Okay. So see, these are the dynamic equations. See, and if you do it manually, see how much complexity is there. If E657, you can identify E657 is where these are the bond names. It will be somewhere. Okay. So what does it denote? E denotes here the effort, means torque. So it is the torque equation. Okay. And another torque equation 6 to 7 at each joint, depending upon the joints. Okay. Like here E718, देखते हैं कहाँ पर है E718, E718 E718 it will be somewhere. I'm not finding right now. Okay. Yeah, it is flow actually velocity information, but we want to know the torque information. Velocity information. So this is the torque information. See 742. 742. This is E742. It's what? It is the torque applied, input torque applied at the joint 3. And see the equation, it is the dynamic equation. Okay, in this way we can with the help of kinematic inputs and this graphical representation, the dynamic equations are automatically derived. This is the beauty of this software. Okay, now what we were doing, considering the simple example of the spring mass system. Okay. Yeah, again connecting to how to get this software and how to simulate. So okay, we can derive the equations, dynamic equations. Then what we have to do, we have to simulate. Okay, so for simulating we need to to perform the numerical simulation, you need to compile the bond graph using a compiler. Okay, either Borland or Microsoft compiler. Okay, then only we can means it is the numerical techniques. Now we have to equations we got. Now we have to solve the equations. Okay. So with the help of numerical methods, we can solve the equations. So by Bolland, you can type the Bolland, okay, in the Google. It is also freely available. Okay. Then what you have to do, like here, once again, I'm going to open this. Yeah, see here, up to this modeling is done. Now we have to simulate the codes. Okay, so we are proceeding. Then here it is asking to compile. So compile through Bolland command line compiler. So what we have to do, we have to set path. So path I have set. Okay, then okay. Then we have to create, compile. Then further we have to proceed for the uh, getting graphs animations. Okay. So Bolland compiler can be freely downloaded. The path for compiler must be given during compiling step in symbols. Okay. This was regarding how to download and what are the other softwares required. So once again, this software can be accessed by clicking this link and then you have to unzip the bond pad. Then you have to further download the Bolland for solving the equations. And the equations are time derivative equations, first order time derivative equations. Okay. So I'm again coming back to the modeling of spring mass system. So spring mass system, there are the external force. So external force I'm modeling here, I'm taking SE, source of effort. Source of effort element here, and there was a spring, so I'm taking here the compliant element C. Okay, and there was inertia, means mass of the body. Here body is a spring mass system. Okay, and obviously there will be resistance. All body will have some resistance and it will resist the deformation. So here we need to take the resistive element. Okay, so in this way, then we have to connect all the elements. We have to name all the elements. Then this is power causality, and this is power direction, then causality, then check integrity, and now it is showing 0 errors, 0 warning. So it means our model is correct. Okay, then we can derive equations. See, we have derived the equations, and here we need to give the, because it is a source of effort, means inputs we need to give. So inputs we need to, like we can give f, suppose f in the term of cost function. So f, before we need to put this star, means multiplication is there, then cos omega. Omega I'm taking here w, then again wt we have written in this way. Okay, and the k2 is what? If suppose K2, it is a very simple system, so easily we can know what is K2. So K2 is the spring constant. Okay, we can write here spring constant. Okay.
Sir, please increase the font size.
Ma'am, I'm unable actually. That control and tracing plus. Okay. No. Page dimension we can increase by this, but the font size I'm unable to do, ma'am. Okay. Now what is M3 here? So M3 is mass. Okay. And R4 is suppose friction. You can name it is user defined expressions. So as per your convenience, you can give the expressions. Okay. So this we have done, and equations. Once again, we can derive the equations. Also, we can save this. Suppose I am saving it. Okay. So one folder is created. Again, I want to check integrity. Zero error, zero warning, because I have expressed as per my convenience. So whether it is correct or some mistake is there. So that's why I did again I check the integrity, then derive the equations. So see the equations, two equations are derived, one for the torque and one for the force. Okay. In this way, now what is the further? We have modeled. Modeling is done. Now we have to simulate. But problem what I'm facing here, because it is a new system, so I installed partially. I need to install like a. It is asking set path. So I have given path of Boolean, and the Boolean is what? The numerical solver. Okay, and this I am clicking OK, then create, then compile. But it is displaying compiler not found at a specified path. That's why I am unable to move, but easily we can do this. I need to interface that. Okay, so in this way we can have a feeling and graphically or through the animation. We can get like what are the values of this, how it is varies, because it is time varying equation. Source of effort means force, how it is varying. That we can visualize with the help of graph. Okay, and also we can do animation. It is animation window, and see this is speed we can control from here. It is the speed of simulation, not the system. Okay. Now, what is happening? Motion planning is going on, means trajectory tracking is going on. This base is in square shape, and there are 6 links, 6 degrees of freedom of robot. So with the help of simulation, then we can animate the frames, and we can run it like a video. I'm going to run. Like see this one. Three space robots are dealing with the object. Object is here hexagonal object. Dealing means manipulating the object. Three space robots are there. Why it is a space robot? Easily one can see that bases of the robots are also moving. Once again, see bases of the robots are also rotating. So the difference between the space robot and the ground robot is that the base is not fixed in the case of the space robot, and also there will be no gravity. Okay. Next, with the help of this software, I modeled the obstacle means obstacle avoidance robot. You can say the trajectory free, collision free. Sorry, collision free robot avoiding two obstacles in the workspace. And the workspace is what? Workspace is the maximum reach of the manipulator. What is happening now? Once again, I'm going to explain it. See, there are two obstacles. One is in shape of hexagonal, other in square. And see the base, below one is the base. And see the first section of the manipulator is already hit to the obstacle. Now observe the second section of the manipulator while tracking the trajectory. It is collided with the obstacles. Now, so I have divided the these into two stages. In the first stage, both the obstacles are hitting to the manipulator. In the second stage, now only obstacle 2 is hitting to the manipulator and the obstacle 1 is not hitting. You can visualize this with the help of this animation. This is my own work. I have done. I have worked. Okay. See, the obstacle 1 is avoided. But while tracing the trajectory, obstacle 2 is being hit to the manipulator. And however, we are getting the desired trajectory, but obstacle is hitting to the manipulator, which is not desired. See, in this, it is the third stage, and now it is completely the collision-free motion planning. Both the obstacles are being avoided. It is not hitting anywhere during the operation. Okay. So this we can do with the help of that software. And there is another software, SIM20, SIM20, SIM20. But it is commercial. But there are a number of added features in that. So one can opt and a student version one can purchase the cost is 10,000 rupees, and even we are planning to purchase that software at least for 1 or 2 license. Okay. So in this way, we can model either 1 degree of spring mass system with the help of Newton's formulation. Already I have told with this approach we have to make a free body diagram of each segment, and this also, like it is a inverted pendulum. Now we want to know what is the dynamic equation. So, and using the Lagrange approach, this is the equation for that. Okay. Then what we have to do? We have to get the kinetic energy, potential energy. Then we have to satisfy the equation. This Lagrange operator, it is a K minus P, means kinetic energy minus the potential energy. Then what we have to do in this Lagrange equation, it is the expression of L, it is a function of L, and L itself is function of K minus P, and means it is function of this theta or theta dot, means angular velocity. Okay. So in this way, by doing these steps, we can get the dynamic equations. Okay. Also, we can consider suppose a 1 degree of freedom and the mass is uniformly distributed mass. Mass is not considered like it is concentrated at the end of the robot. It's not like that. We are considering here uniformly distributed mass. Okay. Then with this approach, we can get the dynamic equations, and that's same for the 2 degree of freedom, either with considering point mass or distributed mass. The approach is same, but depending upon the number of joints, it becomes complex. Okay, and what I'm saying, the Jacobian. So here, this one is the Jacobian part. This middle one is the Jacobian part. So in this way, we can, but I want to show some other, just please 1 minute. I will take a few minutes more. Some more PPTs I'm going to show you. Like what I'm doing, I'm working in the field of space robotics. So the PPT I want to access. Yeah, Jacobian, as I told you, Jacobian, which converts the effort signals into the joint torques in the workspace. But so it is the equation of Jacobian, and the middle one, see the left side and the right side. Left side, these are the Cartesian velocities, and the common of this right side equations, these are the angular velocities, and the middle one, the matrix is known as the Jacobian. And also I have used the PID controllers, which is used to generate the corrected effort signals for the given error signals. So this I have modeled the Jacobian and the PID controller parts with the help of that technique, bond graph technique. So these are some my works, like see, if you see the left side figure and the right side figure, left side figure, and if you see the why not to just 5. Yeah, see this one. Since we're talking about the space robots and the bases are moving, floating in the space, that's why with the use of only PID controllers, we were unable to control the robots. So in addition to that, what we have taken the another controller that is which is named as amnesia removal control. Okay, so without this amnesia removal controller, see, observe the trajectories. There are 3 trajectories by suppose robot 1, robot 2, and a robot 3. And see, focus on robot 3 especially. So robot 3 in the first revolution, it is almost okay, but in the second revolution, the solid line, see, observe the solid line and the dotted line. Dotted line is the desired trajectories, but the solid line is the actual trajectory, means actual behavior of the robot. So the robot is unable to trace the desired path. Okay, but with the help of this amnesia removal controller, see, if you observe the right side figure and trajectories of all the robots, robot 1, robot 2, and robot 3, both are coinciding to each other. Both means the reference and the actual trajectories are coinciding to each other completely. So it is the means we got the desired motions by using the amnesia removal controller. And in this, what I did, impedance control. So along with that trajectory control, I controlled the force. Okay, force also I controlled, and if you see, why not to see the animation directly? If you see this, the left side, the below one figure, the wire is being pulled by the 3 robots SR1, space robot 1, SR2, space robot 2, and the 3. Okay, and see the direction of pulling the wire by the robots. Okay, and another I did it for 2 degrees of freedom robot, and the wire is being pulled vertically by all 3 robots, and the robots are 2 degree of freedom robots. Okay. And see the above peaks, whether we are able to control force or not. Okay. Trajectory controls are the primary, and secondary is here force. So whether we are able to control forces or not. Okay. So see in this 1 degree of freedom robot, maximum value of force we have put 8. It is the limiting force. Okay. And see the graph between the force and the time after reaching. It is it is for all robots, robot 1, 2, 3. All the robots are being constrained by this 8 Newton force. Means the force exerted by the robots are not reaching beyond the given, or you can say beyond the set value of forces. So it is a validation of this work. And what I talked about the obstacle avoidance. So that was done based on the pseudo distance. Okay. The pseudo distance, as per the criteria, if you observe this figure, stage 1, stage 2, stage 3, observe the figure stage 1 and focus on zero value, and there are 2 curves. Okay, one for one obstacle and other for another obstacle. And see both the obstacles are somewhere it is reaching below the zero value. Okay, so criteria is if the pseudo distance is greater than 0, then there will be no collision. If it is equal to 0, then there may be possibility of collision. But it is if less than 0, like in this figure. So in stage 1, you have seen through the animation, both the obstacles were hitting to the manipulator. So with this so with this, I would like to say thanks to dear professor, coordinators, Siddhar sir, and your institute and the participants, faculty members, other research scholars, whoever the participants, and now it is open for your queries. If you have any queries, you may ask. You can interact with me, and I have shared one link for the test. So please, you also go through, and in between, if you have any queries, you can ask. And one more link I would like to share for the test. After submitting, after attempting, you will get to know your score. Yeah, just 1 minute. I'm doing it. In between, if you have any queries, you can ask me.
Hello.
Yes, sir.
Sir, is it over, sir?
Yeah, over, sir. From my side, if they want to ask, they can ask.
Okay, okay. So, respected participants, any inquiries with any doubts clarification with Professor, sir? If you are having any inquiries, any clarifications, please ask your doubts to Professor, sir. Participants, please respond. Hello.
Sir, I want your recording because some internet issues are there, and that's why some disconnectivity is there.
Okay, okay.
And that's why we want your recording because your sessions are very informative, but internet problem is there, and that's why some part is missing.
Okay, okay, madam. I will take care of it. I will take care of it.
Sir, I have shared one more link.
Sir.
Okay.
Now I have shared one more link for the test. So if they want to appear, to appear, they can appear. I have shared two links. One, both are based on robo analyzer, kinematics, dynamics. So you can share, sir.
Okay. 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 Once again, thank you very much, sir, for your valuable presentation on robotic kinematics, inverse kinematics, and robotic dynamics. Today, sir has covered dynamics of manipulator, introduction in Lagrange equation, 1 dy of spring mass system, 2 dy of spring mass system, and 1 dy of concentrated mass system, 2 dy of concentrated mass system, 1 dy of robot manipulators, and also trajectory control of multiple space robots, and also impedance control, simulation and animation results. And Sir already covered some simulation part and animation part with results also. Sir also covered with some case studies. I hope that all these three sessions would be very helpful to the faculty participants and indirectly that knowledge would be very helpful to the student community. Once again, thank you so much, Dr. Vijay Kumar Dalla sir, for his for your lectures from yesterday onwards. Once again, thank you so much, sir, on behalf of Narayana Engineering College, Nellore, as well as the AACT Atal FTP team. Thank you, sir. Thank you once again. And next session will start exactly at 11:30 by Dr. V. Veerana garu, robot simulation part will be covered by Dr. V. Veerana garu at exactly at 11:30 a.m. Once again, thank you so much to all the participants as well as resource persons. Thank you.
Yeah, thank you, sir.
Thank you, sir. Hello,
Hello.
Dr. Birana, sir.
Sridhar, Chup Sridhar.
Sir, ready, sir, Mira?
నేను రెడీనే. ఓకే, నో ప్రాబ్లం.
Hello. Once again, good morning to Dr. V. Virana, sir. Today's second section, subject expert, resource person. Sir is going to be covered modeling and simulation of it is a great honor for me to stand before you all and give brief introduction about our professor, sir. Dr. V. Virana, sir, did his AMIE in mechanical engineering in 1989, obtained MTech from REC Tiruchirappalli in manufacturing and technology, and was awarded PhD from JNU Hyderabad for his research work on flexible manufacturing systems in 2005. He has a rich experience, more than 26 years of teaching experience and 10 years of administration experience. Sir worked as a head of the department in Brindavan Institute of Technology and Science, Kurnool, and also worked as principal of SSN Engineering College, Ongole, and Srinivasa College of Engineering and Technology, Kurnool. Presently, Sir is working as a principal at St. John's Engineering College, Emmiganur. Sir has published 22 research papers in well-known national and international journals, and also presented 24 papers in national and international conferences. And Sir also got Best Paper Award in the year 2015, and his able guidance, two scholars are awarded PhD, and at present, two more scholars are pursuing their research work in flexible manufacturing system area. He acted as a member of the board of studies in the mechanical engineering discipline of G. Pullareddy Engineering College, Kurnool. He is also life member of ISTE, fellow member of the Institute of Engineers, Calcutta, and the life member of the Institute of Valuers. At present, member of the governing council for Sri Venkateswara College of Engineering, Nellore district. On behalf of Department of Mechanical Engineering, on behalf of AICT Atal Academy, I am very much thankful to our Dr. V. Virana sir, professor, principal, immediately accepted our invitation, acted as a subject expert resource person for today's second section, that is robot modeling and simulation. Thank you once again. Thank you so much, sir. Sir, you can start your topic. Thank you, sir. Once again, thank you.
Good morning to all of you.
Good morning, sir.
Sridhar, voice?
Yes, sir.
It's okay.
Very good
So,
morning, sir.
Good morning, all of you. So I am very happy to be with all of you to share some of the points on robotics. So the topic allotted to me is modeling and simulation. So I will start my presentation or points to share with you.
Yes.
Is it clear?
Yes, clear.
Okay, thank you. So we want to model a robot before to actual robot has to be come into existence. So actual robot is too costly. So because of that, generally we will model the robot, and after simulation only, then actual robot is going to be built.
చెప్తున్నారు వీళ్ళు గురువే అనమాట కర్నూలులో.
Sridhar? Hello?
No, sorry.
Can I continue?
Sir.
Okay. So of course, some of the points may be repeated, but I have to do, that means this definition of the robot may be already given to you, but before to model the robot, I have to give the introduction of this robot. An industrial robot, so generally, but of course, so not only for industrial, so many applications we are using the robots. Dr. Samuels are already explained yesterday morning. I am there for that session. So now, in a definition, what is given? Reprogrammable. Why it is a reprogrammable? So for one activity, if a robot is given, no problem for programming is not required. But nowadays robot is too costly, depends upon the different applications. So different robots has to be built. It is not possible because of that. So programming, using of the programming, one robot is going to be used for a number of applications, and that is a multifunctional. So different applications, so one robot has to be do, because of that it is a multifunctional manipulator. Manipulator means what, and what are the parts available in the manipulator? But of course I am not discussing any design part of the components, but so what are the different components which are available to model the robot, and building of the robot, and different elements, different components which are there in the layout of a robot, and finally the programming part of the robot, and finally simulation. I will explain one of the simulator, how to simulate a robot in actual arena. So robot modeling, the first point is creating the part models. So we want to create the part model, we have to know the parts of a robot. So next one, building devices and positioning devices in models in a layout. We'll come back for these points. So robot manipulator consists of different elements. Generally it is a two parts, body and arm and wrist assembly. So what is there in the body and the arm assembly is given on the screen. So in general it is a base, so it contains with the links and the joints. Links and joints, any robot generally contains with links and joints. So link is a rigid component, so which transmits power from one element, one link to the other link. Joint is a joint provides relative motion from one link to the other. So in general for the robots, so this is the way of giving the notations for a links. So base is connected to the link 0, and link 1 there will have a joint 1. So link 0 to link 1, joint 1 is going to be transmits the motion, or we call one joint provides 1 degree of freedom. So depends upon the number of links, it depends upon the degrees of freedom. So generally the robot contains different joints, depends upon the motion. So we are already given joint is nothing but transmitting power from one link to the other link. So joint here, linear joint. Linear joint generally is an input link and output link. It transmits the motion from input link to the output link, maybe in axis or it may be parallel to the axis. So when the link has to be moved in a linear direction, then when compared to the input link to the output link, we use the linear joint. If the transmission of one link to the other link, it is orthogonal in 90 degrees, generally we use orthogonal joint. That means from the input link to the output link, the transmission of motion will be in a right angle or in 90 degrees. So if it is a rotational joint, input link to the motion given to the output link, it will be that means rotation in a horizontal rotation, then it will be rotational joint. So when input link to the output link, it is a twisting, then we will use the twisting joint, or we call it as a T-type joint. So when revolving joint, the input link axis and output link axis is in 90 degrees, then the joint, so we use revolving joint. These are the different types of joints we are going to be used for a manipulator, a robot manipulator. At the same time, so this is an industrial robot generally seen like this. So we will have a body configuration, body and arm configuration, and wrist configuration. I will discuss later the degrees of freedom. So this body in general will have different configurations, depends upon the work performed, depends upon the work volume, the area to be covered. So Cartesian configuration, in Cartesian configuration, Rabo is going to be in, is sometimes we call it as a XYZ configuration, also XYZ Rabo. If the volume is in rectangularly spaced workplace, then we will use Cartesian configuration. So we call it as a LOO Rabo also. So is Cartesian configuration generally have one linear joint, so one orthogonal joint and one more orthogonal joint. So if the depends upon the size of the volume, that work volume, then the this joints and the links are going to be depends. So if the configuration, if the work volume is going to be a cylindrical one, then we will use a cylindrical configuration. So the volume of the work to be covered will is in a cylindrical space. So it contains a twisting joint, one orthogonal joint and one linear joint. We call it as a TLO Rabo also. So in a similar manner, polar configuration, so it having twisting joint, rotation joint and linear joint. So in generally the workspace covered by this is a spherical. If a workspace is going to be spherical, then we will design this type of Rabo. So jointed arm configuration consists of twisting joint, two rotation joints. It is similar to our arm position. So body arm like that. So this configuration will be there. So next one is SCARA robot, selective compliance assembly robot arm. So it is initially designed for insertion purpose or assembly purpose. Later on, now this robot is going to be used for spot welding and punching and press work operations also. So depends upon the our requirement, different configurations are going to be designed for the Rabo. So not only joints and links in a Rabo, so we will have so many other components. So body and arm. So next one is wrist configuration, body arm configuration and wrist configuration. So wrist is going to be hold the gripper or maybe tool, depends upon the application. So it will have 3 degrees of freedom. It's having roll. So one rolling degree and other one is pitching. Pitching and yaw. Yaw is going to be in a horizontal motion, and whereas pitching is going to be up and down. So for a Rabo in general will have a 6 degrees of motion. 3 degrees of freedom will be given to the body and 3 degrees of freedom will be given to the wrist. Whenever the degrees of freedom is going to be increases, generally the cost of the Rabo is going to be increased. So when the degrees of freedom reduces, cost of the Rabo is going to be reduced. If the 5 degrees of freedom will be given, then the wrist will be have given only 2 degrees of freedom. So the yaw is going to be will not be there. It will be given only rolling and pitching motions only. So now the configuration of Rabo will have the either 5 degrees or 6 degrees. So if it is a 5 degrees of freedom, the body will have a 3 degrees of freedom and the wrist will have a 2 degrees of freedom. So generally present Rabo have to work for more number of degrees of freedom. So it will be given as a 6 degrees of freedom. Other than this, body and wrist configuration will have a grippers and tools. So depends upon the application, we will have the we have to choose either you want to be gripper or maybe a tool. If it is a welding, painting, or some ladles, etc., then we will choose it as a tool. If it is a gripper, so depends upon different mechanisms. A lot of grippers are available: mechanical grippers, magnetic grippers, suction grippers, and depends upon the size of the component or workpiece to be hold, so the size of the grippers are going to be changed. Other than this, gears, shafts, gears are used to for acceleration, for speed of the lever, or maybe acceleration purpose. Different gears are going to be used, so either helical gear, spur gear, or worm gear, which are already available in the market, may be chosen for a gears. So pumps and cylinders, so depends upon if it is a hydraulic operated rubber, then pumps and cylinders has to be designed. Shafts, bearings, bushes, coverings, we have to cover with the all the rubber. In general, the covers are going to be used rubber or a plastic or maybe fiberglass, etc. Covers has to be designed. Bolts, nuts, screws, these are the different components we have to model before to model a complete robot. Now, the modeling of the robot, creating part model. So depends upon the requirement, we have to create all the parts in a software, whatever the software we are going to use. Later I will discuss the different softwares which are available for model of the robot. So simulating packages, then building devices. After creating all the parts, these are the parts which are required, already discussed. Body, it may be contained links, joints, and wrist assembly, or grippers, end effectors as a gripper or maybe tool. So after creating all the parts, so we have to be assemble the parts. So we have to assemble the device as a robot. Later this device, robot is going to be placed, positioned in a layout. So with respect to the different elements, different components which are available in a layout, maybe conveyor, AGV, or maybe a CNC machine. So different conveyors with the respect to the position with coordinate system, we have to use the coordinate system, and the robot has to be placed in the layout. Later on, motion distinction layout. So with respect to the different components, what are the motions, what are the distances a robot has to be moved. So then this robot is going to be programming. So we have to program the robot using of the different methods. I will discuss later. So now, after modeling the simulation, before to start the simulation, so the application point, we have to define the problem. What is the application we have to do by the robot. So this simulation is two types. One is discrete simulation, other one is continuous simulation. In discrete simulation, what happens, different components are going to be separately simulated, whereas in a continuous simulation, with the integration of the different elements are going to be is a dynamic. So different elements has to be simulated at the same time, maybe conveyor with robot and CNC machine, etc. So if have to be simulated only robot, then it will have a discrete simulation. With respect to the other, so it will be a continuous simulation. I will show a small package as a small component how it is going to be manipulated with this. One minute, before this I want to show the package. So I will show that later. So after designing, what happens, define the problem, design the study, then design conceptual model, then formulate inputs and outputs of this process. So now హలో హలో
సార్
కనిపిస్తుందమ్మా ఎందుకంటే నాకు కంటిన్యూ
కనిపిస్తుంది.
ఓకే రైట్ సో many packages are available for a simulation of the robo. Almost number of packages, webboards, gazebo, etc. Then for a simulation to show have taken the software which is available. So this is a Robologic. Robologic will be like this. So this is a robot has to be simulated with the two conveyors for pick and place and for welding, etc. I will show later. For this one here, see the screen, this will have a teach pendant. So this robo programming methods having 4 methods. Robo can be programmed 4 methods. So one is manual method, walkthrough method, lead through method, and offline programming. So in general, manual method is going to be is very not convenient today. It is oldest method, so it's not used in a conventional sense. Conventional sense, we can't say this as a programming. For example, for a lift, if you board a lift and if you press a 1, so generally it's going to be for the first floor. So what happens, there will have a small program where there will have a sensor. When it touches the first floor sense, then it stops. If we given a second floor sensor, then it stops to the second floor, like that, using of the stops. So when the programming is done, it is the oldest method, that's called manual method. But because of the nowadays the software and etc., now this method is not going to be used. Next one is walkthrough method, programming of the different robos for a simulation. Then these are the different methods are going to be used. But simulation, so we can use offline programming, but programming methods of a robo is generally manual method and walkthrough method. In walkthrough method, what happens, so in a particular environment, robot arm is going to be taken by the operator and it moved from the different places. Different points are going to be saved. The application, suppose if it is a pick and place of operation, a man is going to be carry the robot arm or a gripper, and then it moved. The work has to be done. So picking place, then afterwards, after picking the robot, then the delivery place. After completion of this, what happens, so the simulation, that means the same operation has to be repeated number of times, then this operation is going to be taken place. So because of the practical environment, what happens is going to be robo production is going to be stopped. So no production taken place at this time. So whereas offline programming, what happens, so generally the robo is going to be simulated offline. The actual activity is going to be taken place. That means production time is not going to be wasted. So in walkthrough method, generally lot of negative, that means application point of view, the production has to be stopped, so it's not advisable. But sometimes simulation will be taken as a offline programming. And of course, this offline programming, when compared to the online programming, what happens, there have some problems. Because of that, nowadays they are using hybrid programming also. So whereas offline programming is done 2 methods, one is lead through method online, and lead through method offline. So this screen which is shown is this is a lead through, similar to lead through, which is having, if you see, this is a positive, a negative, this joint, rotation of the joint, and this will be the a negative. Using this method, by moving, the program is going to be done. So this A1, A2, A3, A4, A5, these are used for the joint rotations, either positive or negative. And also for x-axis positive, y-axis y-axis is negative, z-axis is positive, z-axis is negative. This is for gripper open and this is for gripper close. And here it is a conveyor on C1. First conveyor is on, the workpiece is moving. This is for reverse of the workpiece. This is off. In a similar manner, there is no workpiece on the conveyor to C2 on, C2 off. C2 reverse, C2 off. So programming using of this, we can move the workpiece, we can move the robo, and we can so we can move the robo to pick the component on conveyor 1 and move to the conveyor 2 using of these motions, and from the home position we have to move it, and each and every place we have to save the these positions, and after delivering the workpiece on the second conveyor, bring it back to the home position. Then if we repeat it automatically, so the program is going to be run. This is the programming way. So using of the teach pendant method, so this is having its own advantages, whereas the programming, if you want to program, number of programming languages are available. Here we are having, after completion of saving, then if you run, then the program is going to be run. So from the main menu, instead of moving this teach pendant, then we can use the program. There it is, program. So using of this, we can program different number of languages are available for programming. So we will discuss later this, what are the programming languages, what are the way of programming. So using of the commands, so we can program. Then after completion of the program, then we also home, then so program, we have to load the workpiece. After saving this, then what are the different programs we are already prepared, so that program can be loaded. Then after loading the program, then we can run the program. So these are the different methods which are available for simulation purpose. Here the different programming languages which are available is, so first programming language which is going to be developed in 1973, the programming language is called Wave, W-E-A-V-E. So Wave language, later on, so number of languages are going to be come depends upon the requirement. The next one is VAL, so VAL. So this is this programming VAL is going to be Vector Assembly Language. So this is developed by the IBM. So later on, Microsoft also developed some of the languages. Depends upon the this language is similar to our programming languages. Similar to our programming languages. So it contains, the programming language contains constants, variables, and motion commands, end effector commands, etc., etc. Robot programming language, so different languages we have to is similar to our C, C++. So Java, I don't have the program, I don't know the programming methods, but robotic programming languages, that means CNC programming and robotic programming I have seen. So here initially we have to define the variables. Suppose we want to define the different components in the simulation area, define A1, suppose a point XY coordinate, or if it is a 3D space XYZ. So we have to define the different points. So from this point, initial position to different points, if it is a intermediate point, we require to stop the robo. So what happens? So that different points, this point. So next one more point, we have to define all the points in between from the home position to the workpiece to be handled. So later on, motion commands after defining these points. So if we are moving this with the teach pendant method, so if you want to program, what we have to do is, so the different points from the home position to the different points we have to define. After defining the points to be moved or moved on the space, we have to give the motion commands. Move A1, so move to the point A1, or moves A1. So if it is a path, we are already created a line or arc, so moves A1, it goes along to the path what we have given. So if you want to control the speed of the robo in between, then so we have to speed 60 IPS, inches per second, or speed 75. So the speed also can be defined along the path to be moved by the robo. So later on, you suppose this robo has to be stopped at a particular point to select a component. So here A1 means here the workpiece, which is some point we can define. Then we can say here this is the component. Define. We have to define the different points. So where the workpiece has to be handled like that. So next one, paths also can be defined. Define path 1, move path 1, define route, moves route. So like that. Later on, end effector commands, open, close. So using of all these commands, we can write a program for a simulation. So by using of the programming methods, or maybe using of the teach pendant method, a robo is going to be the robo is going to be programmed for a particular operation or particular activity. So different languages have different syntax. Depends upon the requirement. So availability. So we have to know that particular language. Now come to the simulation. After defining of the problem, design the study, design the conceptual model, formulate inputs, assumption, and process definition. Why we want to assume? When compared to the simulation and the actual environment is going to be differs. So depends upon that. With some assumptions, we have to formulate the model. Then build, verify, and validate the simulation. So after simulation, after simulating the particular activity, then so we have to experiment the model, how the experiment is going to be operates. Is there any problems when actual environment and to the simulation environment? Then after documentation, then we will go for the cycle. But so here the programming methods already discussed: manual method, walkthrough method, lead through method, and offline programming. So in the lead through method also we are having so two methods. One is online lead through and offline lead through. So online lead through is going to be actual environment, the production loss will be there. So better what we have shown now. Oh, Sridhar, hello, hello, hello.
Sir, hello.
Screen ఏం కనిపిస్తుందమ్మా?
కనిపిస్తుంది సార్.
రబో కనిపిస్తుందా?
సార్
ఏం కనిపిస్తుంది? రబో కనిపిస్తుందా లేకుంటే పిపిటి కనిపిస్తుందా?
రోబో కనిపిస్తుంది సార్.
Okay, okay, right. So In online simulation, what happens? So the production loss will be there. So because of that, after completion of offline simulation, it is better to use it for the online simulation. So now these are the different simulation softwares which are available. So number of softwares are available. Depends upon the requirement. We have to choose one of the simulation software.
Excuse me, sound is not there.
Emma,
Sound is not there.
sound is not there. But I do not know. Francis,
ఎస్ సార్
సౌండ్ రావట్లేదా?
వస్తుంది సార్ వస్తుంది వినిపిస్తుంది
వస్తుంది సార్ క్లియర్లీ ఆడిబుల్ సార్
సార్ రావట్లేదు. హలో సార్.
హలో సార్
Ah,
ఇస్ ఆడిబుల్ సార్ వాయిస్
okay, okay.
క్లోజ్ అయిపోయింది కూడా వీడియో.
1 minute.
హలో సార్.
ఒక్క నిమిషం అమ్మా, నాకు కనిపించట్లేదు. ఓకే అమ్మా. సో కనిపిస్తుందమ్మా ఏమన్నా?
లేదు సార్, అంటే జస్ట్
ఒక్క నిమిషం. ఐ డు నాట్ నో. ఓకే
సార్ ఇందాక వీడియో కూడా ఆడియో వినిపించలేదు సార్ ఏమి.
ఆడియో వినిపించలేదమ్మా. అది
కొంతమంది ఎవరో వినిపిస్తుందని చెప్పారు కానీ ఆడియో వినిపించలేదు సార్.
ఓహో ఓకే అమ్మా, చూస్తానమ్మా ఒక్కసారి. ఓకే, సో నౌ ద ప్రోగ్రామింగ్ మెథడ్ ఏ స్మాల్. ఇప్పుడు వినిపిస్తుందమ్మా? హలో.
ఓకే సార్.
So for pick and place robo, how the programming will be done if small simulation is given, so are shown just now. I will show one more. After completion of this pick and place simulation, the operation is going to be will be like this.
So it's not audible, sir, generally.
రావట్లేదమ్మా నాకు, ఏదో టెక్నికల్ ప్రాబ్లం, నాకు అంతగా టచ్ లేదు. సారీ, ఇట్స్ ఓకే. For pick and place after completion of the program, so simulation finally the operation will be like this. Say pick and place. So this is the method. Oh, Hello. Hello. Hello.
Hello.
So after each and every part is going to be modeled, but after design, actually we have to design initially the parts. So for designing different requirements, work part size, etc. After getting all the required information,
Hello, sir. Hello.
Hello, sir.
Hello, sir.
Sir, where are you, sir? Hello.
Sir, stuck అయినట్లుంది సార్ సార్ది ఒక నిమిషం.
Okay. Dear participants, due to power cut, the session will continue within 2 minutes. Sorry for the inconvenience. The session will continue within 2 minutes. Please cooperate. Sorry. Madam? Hello? The power problem in this alternate చేస్తున్నారు.
Yes, sir.
Within 2 minutes, session will again will continue within 2 minutes. Hello?
Hello, sir.
Madam,
చెప్పండి సార్.
madam, madam. Sir, okay, sir. Sir, where am I, sir? Hello?
hello. Sridhar.
Yes, sir. Okay, sir.
Okay. Thank you very much. I'm very sorry. So there will have some technical problem because of that. So the system failure. So now modeling and simulation. what we have discussed briefly, different points. So industrial robot is required different components. After designing of the different components, we have to create in a model. After modeling, we have to build the device, maybe robo and etc. Then this robo is going to be positioned in a layout and actual environment, like similar actual environment. So with respect to the different elements in a layout, what we have shown a simulation component, conveyors, and maybe it is a machine, AGV, etc. After modeling, after keeping the layout, then we have to define the device's motion. So what is the speed has to be followed, what is the acceleration, what our pickup, what is the force we have to be used for the pick the workpiece, and delivery point, etc. Then so we have to use the behavioral programming. So programming with the different programming methods are available, number of languages are available, and number of simulation softwares are available. Then after programming, that depends upon the requirement, maybe different program, that means either manual method, offline method, or online method. So using of this after programming, then so the simulation will be executed. So after simulation, but still for the actual environment, that will have a small changes. We have with some assumptions, the simulation has to be implemented for the actual environment. So now, so different methods. So robotic programming languages, the initial languages which are Wave, AL, and 9C, 9D, Atopos. Atopos is going to be developed by the IBM. So AML, Rail, MCL, etc. Each and every language have its own syntax. So using of the syntax which is given for the different language, that means depends upon the language what we have going to be chosen. So that will have to be programmed for a particular activity. So now robot simulation softwares, number of simulation softwares are available now today in market. So webboards, Gazebo, VREP, etc. For demo purpose, what I have chosen one of the programming language, one of the programming software, that is Robotics. So this using of the Robotics. So how the simulation will be done is going to be shown to you. So once again, I will show that. So using of this, what happens, either maybe the direct, that means using of this teach pendant, the what is the screen we are seeing. So here we are having the different this is the rotation of A1, the joint 1, a joint A1. So using of these joints are number of cameras are which are available. This is camera 1, camera 4, this is camera 2, so camera 3, camera 5. Using of all these cameras, so what we have to do is the component for pick and place, or maybe painting, or maybe welding, depends upon the application. Different application we have to simulate. After simulation, so after simulation, then is going to be implemented for the actual environment. Either
Hello, sir.
ఏదో ప్రాబ్లం అయిందమ్మా మళ్ళీ.
సార్, హలో సార్.
ఏదో ప్రాబ్లం అయింది శ్రీధర్, కనిపిస్తుందా?
కనిపించట్లేదు సార్.
ఏదైనా స్లైడ్స్, ఏదైనా వేరే స్లైడ్స్ ఏమైనా చూపించండి సార్.
అదే లేదు, ఒకటి వీడియో కోసం చూస్తున్నా, అది వస్తుందా అని చూస్తున్నాను. 1 minute. ఇప్పుడు మన స్క్రీన్ కనిపిస్తుందా?
Okay, sir. Fine with. Yes, visible, sir.
Okay. This is one more application for painting rubber.
ఆయన అడిగాడా డైరెక్ట్ అడిగాడా?
Okay. Hello, Sridhar. Hello.
Sir.
వినిపిస్తుందా శ్రీధర్?
Okay.
Okay. So briefly, the what is the modeling and what is the simulation is given a Rabo using of Rabo logic, a small how the online and offline programming is going to be done, and for particular applications for painting and welding. So welding, which is after the simulation, the actual environment, how the Rabo logic is going to be behaved will be given using for the welding video. So now after completion of this simulation, that means modeling and simulation. So is there any queries, please?
अरे पण कुठं बसतो तो?
Hello friends.
ते आता तू काय कारण सांगतो त्याचं काय रेग्युलर नसतो ना.
Hello, not clear, please.
रेग्युलर कुठं असतो तू? सांग बरं, आज मी काय देणार आहे मुलांना?
Is there any queries, please?
ऑनलाईन ला काय प्रॉब्लेम आहे मला ते सांगत नाही. आतापर्यंत किती मार्क्स आपण ड्रॉइंगच्या? किती घेतला? 2 2 घेतला का 3 घेतला?
Hello.
ड्युटी दिली ते परत होणार आहे आता युटी उद्या परवा. मी आता पाठवत आहे. आता मॉक टेस्ट झाली. For A1 today there is a mock test. ओके. हा त्याचा डिटेल देऊन द्या सर मला. तुला कुठली अडचण असली तर
Hello, sir. Hello.
कोण आहे ते?
Hello.
ओके. म्हणजे मोठी फॅमिली तुम्ही बोलून घ्या त्यांच्याकडे. बोलून घ्या त्याला असं पॅकेज द्या म्हणजे ऑनलाईन म्हणजे 1 लाख असं.
Hello. I'm sorry, once again, some technical problem. I'm very sorry. Is there any queries, please, on modeling? Hello.
No, sir. It is clear, sir. We can able to understand.
Okay. Sridhar?
Sir. Yes, sir.
Okay.
You can continue, sir. You can continue, sir.
I have to continue.
Sir, please.
Okay. So, this is robot simulation softwares. So web boards is different softwares which are available in the market. So we have to choose the depends upon our application. We have to choose the different softwares. Suppose web boards. So is developed by the Robotics, which is in C, C++, Java, Python. So these are the different languages which are going to be used for the different softwares. So whereas Gazebo is going to be developed by the George Robotic platform, and VREP, which is very much useful for the advanced 3D. This is developed by the designed by the Cochlear Robotics. So this is most useful for the 3D robotics. And Microsoft Robotics developed a studio is called Microsoft Robotics Developer Studio. So which is developed in C# and Visual Studio 19. So these are the softwares which are available in the market. So number of softwares. So for our simulation purpose, we can choose any one of the softwares like RoboGuide. So one more 3D software which is available, and MotoSim. and Robo Expert, Robot Studio, Robot Sim, and Simply Cube, work cell simulation, AX on Dex, and like that. So this Robo logic is going to be very much convenient and simple for this one. That's why I have chosen this Robo. Uh, 1 minute. So this one I have chosen because it is very simple. So using of this software, so we can simulate the components, and later on we can adapt for the actual environment. So this home program, that means we want to program is what happens. Is a program using of this already number of programs are going to be designed. That means we can simulate the number of programs and save. Depends upon the requirement, we can load any one of the program. That means depends upon the application what have to be done on the actual environment, that program is going to be loaded, and activities can be done. After completion of that, suppose so one more activity has to be required, then the second program is going to be chosen from, and we can load the program, and we can simulate it, and we can for actual practice we can do this. So now these are the programs. For a new program you want to create, so go to the program and take is a new, then give the program name, Rabo1, etc. And no comments. Sridhar? Sridhar?
Sir.
So నేను ఎండ్ అప్ చేస్తాను.
సార్ ఏదైనా క్వశ్చన్ సెషన్ ఏదైనా చూడండి సార్, 10 minutes.
అదే ఎవరైనా క్వశ్చన్స్ చేస్తే డిపెండ్స్ అపాన్ దట్ ఐ కెన్ ఆన్సర్ ద క్వశ్చన్స్. సో
హలో
is there any queries please?
Hello.
If there any questions, then
any inquiries please? So sir is waiting for your inquiries, please respond.
no one is responding. So is there any interaction session, then we can have.
Excuse me, sir. This is Vimla Rani.
Yes, madam.
The software that you're using is an open source or an?
It is a open source. It is a open source, madam.
Okay.
It is
So
a
if you
open.
could-
It is available for 30 days. 30 days. Then later on, we have to purchase it. Depends upon our requirement.
Okay, sir. Thank you, sir.
Any
It is a open source only. Next.
any other inquiries please?
Any Robo manipulator, or maybe simulation, or maybe in modeling. Is there any queries please?
Hello. Sir, hello.
Hello.
Hello, sir.
Sridhar, I'm here.
ఏదైనా డెమాన్స్ట్రేషన్ ఏదైనా ఒకటి మోడల్ ఏదైనా
Model.
డెమాన్స్ట్రేషన్స్
Okay, okay, okay. 1 minute. Okay, no problem. Okay, 1 minute, Sridhar.
Okay.
Okay. 1 minute. Waiting. కనిపిస్తుందా రబు? శ్రీధర్ కనిపిస్తుందా?
సార్
కనిపిస్తుందా?
సార్ లింక్ జాయింట్స్ దట్ స్లైడ్ on the screen, sir. Yes, now it is visible, sir.
Okay.
చేసినా వద్దు
Sir.
Okay.
Is it audible, sir? Sir.
నాకు audible గా ఉంది.
What software is it? Which software we are using, sir, for simulation and modeling?
Robotics.
Logic. Is it available online, sir, for a student point of view?
Yes, it is available.
Okay. So, is it required any license?
30 days no license is required. After that we have to purchase it.
Version is free.
30 days free version.
Okay. Is there any other softwares are available in a similar fashion, sir?
Number of softwares are available. I have given so many list. Number of we have Webboards 3D, Gazebo, VREP, etc. Number of softwares are available almost. So I have given 23. Actually, the list is numerous.
All softwares are available for students' point of view in a free version.
Yes.
Okay.
The only thing is there's a limited time offer will be given. Later on, for application point of view, you have to purchase the softwares.
So if you want to do any research work in this particular area,
it is available. It is available.
Okay.
So for research work, for limited purpose, they are available.
Okay.
Sridhar, it's not audible now?
No, sir, not audible.
Not audible. I don't know how some technical problem. So, but
if possible, you can explain, sir. While
should have been audible.
This is visible, not audible.
Not audible. Oh, so it's a small mistake.
The procedure
is given. So audible, the audio, so some technical problem. So for a particular for this it is a pick and place. So the different activities are going to be identified. So these are the steps which are going to be done for the particular activity. These are the 5 steps. So step 1, identify. Later on, for one particular activity, these are the different for particular work. So for pick and place, so keeping that means picking one workpiece in the conveyor 1, and for delivering the workpiece on the conveyor 2, these are the different 12 activities are going to be identified. So using of these 12 activities from the home position, so the workpiece is going to be picked on conveyor 1 and conveyor 2. So audio is there. That means, so from technical problem, so I don't know, the audio is not not possible for the participants. I'm very sorry. So, but audio is there. The sound is very good, but some technical problem we are not hearing. So later on, these 12 activities identifying. So now the gripper position, that means, so from position, home position from 1 to the box position 2. So instructions are giving how to pick the workpiece from position 1 to the position 2. So for any particular position, so you want to give the comment. Suppose this is the position 1 or home position, or for the conveyor 2, then we can give the comments for that. Instruction set. So for actions, we can use forward, reverse, off, where we have to stop for the conveyor 1. Any comments we can give it here for a particular program. Conveyor 1, forward instruction from the home position forward to conveyor 1. So wait. So for the workpiece, it has to wait for some time. So here we can give a wait for 12 seconds. So wait for the pick up the workpiece at conveyor 1. So I'm very sorry because there is no sound for the simulation. If there is a instructions and a sound will be there, then it will be better. But I don't know, the sound is not available for the participants. I'm sorry for this. Thank you very much for the participants, and I am thank you, sir.
Thank you so much. Very much. Principal, St. John's College of Engineering, Karnool. In his sir has covered in his lecture various topics like robot manipulators, end effectors, different components of robots and robotics. The market, nearly 24 softwares are being available in the market for modeling and simulation, and sir also given some demonstration about software, pick and place mechanism, and demonstration of pick and place mechanism application, how to modeling and how to simulation, and what are the steps for creating a program, and what are the languages used for modeling and simulation. Due to some technical problem, small interruption is there. Sorry for the inconvenience. Once again, I thank you so much, sir, for your very good presentation regarding this modeling and simulation. I hope these topics, this lecture might be very much useful for the faculty who are going to do their research work in that particular area. Now, 1 hour lunch break from 2 to 3:30. Already robotic components assembly topic already scheduled, lab section already scheduled. That will be taken at our own lab, robotic lab, which already established in association with IIT Mumbai. Mr. SD Parvaz Hussain, technical manager, IIA Club, sir will take that lab session, a wonderful lab session. Once again, thank you so much. We will again rejoin at 2 o'clock exactly. Once
Thank
again,
you.
participants maintain more than 80% attendance is compulsory as per ACT Atal Academy rules. I request to all the participants try to maintain that more than 80% attendance. Once again, thank you, sir, Dr. Veerana, sir. And again, thank you so much to all the participants. Bye.
Thank you, sir. Bye, sir. Sir, shall we leave the session, sir?
Yes, sir. We will.
Sir, you may leave and just join at 2 o'clock, sir.
2 o'clock, ma'am. Okay, ma'am. Madam, will you send the feedback form, please?
Sir, already I sent, sir.
Yeah, thank you, ma'am.
Okay, sir.
Hello. Hello, sir. Parvaz, sir. Okay. Thank you, sir. Thank you. మీరు వీడియో ఆన్ చేసుకోండి సార్.
మధ్యలో వీళ్ళు వచ్చి అప్లికేషన్ ఒక నాలుగు కనిపించలేదు అంటున్నారు.
Hello. Hello. Yes.
ఇంట్రడ్యూస్ చేస్తాను. జస్ట్ ఇంట్రడ్యూస్ చేసిన తర్వాత. Hello.
Hello, sir.
Hello, madam.
Sir.
Okay. Now time is 1:59. One
Yes,
more minute is.
Okay.
So we will start the session exactly at 2 o'clock. Okay. Yes. Good afternoon to one and all. So good afternoon, Parvaz sir, Technical Manager, Aicte Hyderabad, and also welcome you, sir. Warm welcome you, sir, to this afternoon session on robot components and assembly lab session, and also warm welcome to all the participants across the country. Now it is a great honor for me to introduce Parvaz sir. Sir, presently working as a senior software engineer, and also previously sir worked with Infosys for 6 years, 3 months, with various positions like systems engineer trainee and senior technology analyst. Simultaneously, sir has established his own organization named Innovate Invent EduTech Private Limited. Sir is the founder of this IA Club Hyderabad, and sir has given so many talks in various reputed institutions like IITs, NITs, more than 200 plus talks, And also, SAR has trained 30,000 plus students in various domains like automation, robotics, IoT, etc. And SAR has developed so many products. It includes Robots 9, Arduino-based educational kit for learning of school kids, kinetic art installation, bird sound simulator, Botanical Garden, Hyderabad, installed at Botanical Garden, Hyderabad. I proudly say that we are also tied up with the II Club. With the support of II Club, Association of II Club, past 4 years, so many projects, so many developments are being made by our students. And as already told you that with the support of II Club Parvaz sir, we have designed and developed a robo for providing services to the COVID-19 patients at Narayana Medical College. Once again, I welcome you all to this afternoon lab session. I request SD Parvaz sir will continue his session. Thank you, sir. Welcome you, sir.
Hello, all. Hope you can see me. Thank you for the warm welcome, sir. I'm extremely happy to have this opportunity. So, sure, I'm getting this. Getting this up.
Hello.
Can you please Narayana live class, NEC host.
Hello, sir.
Hello. Yes.
Sir, voice is not clear, sir.
I'm able to hear myself. Can you mute Narayana live class NEC host? Thank you. Now, I hope everybody is able to hear me, right? Okay. Please mute it.
Sumanto. Hey.
Hello. Yeah. Oh, so thank you, sir. So that was my short introduction, and I've been training students for a very long time on robotics. So now this faculty development program, I'll be covering, my agenda would be covering the components and also giving you information about different types of modules, sensors, and what all we have to build a robot and what it takes, what are the steps. So I'll be going through that procedure. Just a second, guys. I'm really able to feel that echo for some reason here. I don't know what is the reason. I'm able to hear my own voice. Hello. Hello, guys. Just can you hear me now? Okay.
Yeah.
So I guess it was a problem from my side. I'm sorry, my bad. So yeah, let me start this session by sharing a small deck. Let me share my screen. I hope you can see my screen. Yes.
Yeah, but
Yes, sir. Yes.
it couldn't be readable, sir.
Robots. There is none over there. Slide with two robots on it. Anyways, I'll just. Hello. Hello. Hello.
Is it audible, madam?
Sir, it is
Yeah, audible.
It is audible. It is audible.
Sorry, guys. Give me 1 second.
Your voice is very low, sir.
Hello. Am I audible now?
Okay, sir. You speak.
Madam, okay, na?
Okay, sir. Sir voice కొంచెం లోగా ఉంటుంది. హలో సార్ బ్రేక్ వస్తుంది సార్ వాయిస్ క్లియర్ గా రావట్లేదు.
1 minute, madam. 1 minute, please. Wait for me.
Voice is breaking, sir.
Unmute చేయండి. దీంట్లో నుంచి వాయిస్ వస్తుంది.
హలో
Sir, again.
Can you hear me now?
ఓకే సార్.
Hello. I guess I have to stop my video for good audio quality. I don't think we need video since I'm sharing my screen. Let me share the video later when I'm going to give you a small demo or something. So let me know if you can see my screen. Okay. So let me know if you can see my screen.
Screen share is
Hello.
Share కాలేదు.
it's not visible, sir.
Share కాలేదు.
Yes. Okay, I guess now it is shared, right? Okay. So robots, basically robots. So what comes to our mind when I say the term robot? So we all think about machines which are there in the manufacturing units, or the machines that are being utilized in outer space, where we are sending rovers onto the moon and Mars. And there are also machines that we see in movies like iRobot, or our own movie, which is Robot made by Rajinikanth. We have a robot named Chitty. And also we have real-time robots which have highly sophisticated neural networks and artificial intelligence based technology. For example, Sophia and other robots. Now, even some of the companies like Boston Dynamics are doing a great work designing animal robots, which are equally performing the stunts equally, important and also very efficient walking and jumping type of techniques in the using machines. So how is this possible, and how these robots are being built? So these are the things comes into our mind, but some of the people think that robots are not machines like these. They are machines like which looks like human and which walks like human, just to imitate human and do some actions. But according to me, I would define robots as something, a mechanical machine that can, that can help us do a complex job in a very easy manner. For example, I would consider a JCB crane a robot, definitely, because it is a huge machine that digs into the ground easily, just like that, by mechanical control. So these kind of machines are also can also be called as robots, but the only thing is the way they are controlled is not autonomous. So robots can be categorized into three types: autonomous, semi-autonomous, and fully automatic. Like fully autonomous based on a lot of artificial intelligence and machine. Semi-autonomous are more majorly robots that are pre-programmed, and also they have a couple of sensors to give them feedback continuously, and based on that feedback they operate accordingly. And also, let's talk about manual robots. Just now we have discussed about manual robotics, which is like um, you know JCB cranes or elevators, which has a predefined program set of instructions that are being controlled from outside. And help us to achieve our day-to-day tough activities in a very easy manner. So that's a short intro about robots. I'm not here to give you an intro about in the morning. I'm here to give you introduction about the procedure, components, and how to build robots. So basically, we have certain things like what are the main essential parts of robots. And before going to main essential technologies or top skills that are needed to build a robot, I would like to first discuss about what are the various areas that robotics is being applied these days. And I would say, surprisingly, robotics is being applied in the educational field more than any other field. So educational field, you might be wondering, how is it? Like robotics is being utilized in industrial area, and you might be expecting that answer from me. But I would say robotics is nowadays on a large scale for the education purpose. Robots are being used. How? Because because of the introduction of boards like Arduino or any other microcontrollers, we are utilizing those, and we are able to program certain things. So even small. Hello? Hello? Guys, can you hear me? Hello? Cutting. Hello?
Hello, sir.
Ma'am, can you please give me feedback? I'm not able to understand if I'm
No,
being
your
very
sound is
clear or not.
clear, but some noise is coming in between.
Okay, now, like, were you able to follow whatever I was trying to say from the start?
Yes, sir.
Okay, that is cool. Thank you, sir. Thank you, ma'am. Please give me feedback. I'm not able to understand. The network is
Okay,
really
no
bad
problem,
here.
sir. No problem.
Okay. So I was saying the applications of robots in the educational field. So there are robotic kits that are being built around, and these kits are very are laying a foundation for learning robotics, and the components which we are using to teach these kids uh, uh, to teach school kids are really very cheap and are available in the market. Even online they are available now. Utilizing these particular components and building robots is enabling students to create their own imaginative robots. So robots, in the sense, you don't imagine children creating industry level robots where they assemble all sorts of cars and fans, like car in the assembly line of the car production or bike production or whatever. So they are not building that kind of robots. They're utilizing their logical reasoning skills and trying to code that into a machine and making it. For example, let's say what I have to do if I want to make a small robot that moves in the first 3 seconds, less than 4 seconds, and moves in the forward direction again for 5 seconds. So this is the particular task. If I give to any student, how he should do it. So this is a very simple task. All he needs is 2 motors and a simple microcontroller where he can write the program. And microcontroller should have a timer, and the timer takes that particular delay of 4 seconds or whatever the task I have given, and he will code it. Now, what if I give another task to him where he has to build a robot that climbs onto a table and moves around, and moves around the table and does not fall. So what he has to do now? He has to go and search for a sensor that keeps this robot from falling off the table, and that particular sensor should be attached on the front of the robot. And once he reaches to the table, the sensor should give a feedback, and you need to have a loop running in the program that takes a continuous feedback, and the robot works accordingly. So these kind of logical things, even children can think and build robots on a small scale, very small scale. That's what we have been doing here. For the educational purpose, we are developing kits, and in colleges also, like students whoever are studying engineering, they should be attracted towards these things first, and then eventually they will be evolved slowly towards industrial robotics, which is very much similar to what I just told. But the only difference is, instead of microcontrollers, we play with PLCs. Instead of small scale motors and wheels, we play with real time industry grade big size motors. Load bearing is very high. So coming back to our like robot. So to build a robot. Is I think we needed basically to see what kind of problem we are trying to solve here using a robot. Is it a assembly line problem, or we are trying over, or we are trying to do some research where are we trying to build prosthetics, or are we trying to do some research developing advanced sensors that can mimic the sensory organs of our own human body. So based on the purpose, we need to come up with an innovative design. So why design is really important, I'll tell you. Design design is like the first step of the 100 steps to build a robot. So the first step is to have that idea and then come up with a beautiful design. So this is where the mechanical branch is excelling actually, where if you have a idea to build a robot that can dig holes or into the ground or explore on the moon, you need to have a particular
Sir, your voice is breaking, sir.
a humanoid robot. Now the
Hello, sir. Hello, Parvesh, sir.
ma'am.
Sir, your voice is breaking, sir.
Yes, ma'am. Hello.
Hello, sir.
Hello.
Sir,
Can you hear me?
your voice is not clear, sir, generally. About 2 minutes, just from 2 minutes. Sir, can you, sir? Parvesh, sir. Can you session, sir?
Yes, ma'am. Can you hear me?
Okay, sir.
Can I join from the just a second, ma'am. I'll join from sir's mobile only.
Okay, sir.
Hello.
Hello.
Yes, ma'am. Can you hear me now?
Yes, sir. Yes, sir.
I hope this is very clear.
Okay, sir.
Okay. So, anyways, so I was saying about design. The importance of design is, let me give you an example of building a humanoid robot. There are different types of humanoid robots. One of which is Honda's Azimo. Azimo robot is a very advanced walking type of robot where they have all the joints mimicking the legs of the human being. And if this if this robot is being built, imagine what kind of design phase they have been gone through. And this design phase basically is done by a lot of mechanical engineers. And when we talk about how, the main answer is different types of designing softwares. The first thing is AutoCAD, CATIA, SolidWorks, ProE, Inventor Professional, ANSYS. All these things are the designing softwares where we design things like these. And so are you able to see my screen? I'm sharing something.
Yes, sir.
Yeah. So the design, like this, we will design each and every part. As you can see on the screen, I'm showing a humanoid hand, like a robotic arm, where we have servo motors and the clamps fixed together, where the center of mass is being calculated and everything is pre-calculated. And based on that, we do a lot of iterations while designing a robot. And we do a lot of innovative stuff over there. It's not a very simple design, just like that you take a motor and just you keep a stand to a motor. It doesn't work like that. We have to do a lot of research to see how much load, a lot of calculation, sorry, not research, how much load a particular motor can bear and what are the types of motors available, which type of motor should I use, and how much amount of power is going in a motor, and can our power source accommodate all these motors, and what is the tip of the what is the tip of the edge of the arm where it can bear the load, and stuff like that. So if this much of calculation is going onto the hand itself, just imagine how much amount of work will be going onto your entire humanoid robot. So this is why design is very important, so that we don't make any mistakes in the production and lose a lot of money iterating on the real-time environment. So design and simulation is very important. So we use these kind of things. So to talk about design and simulation, let me share a small image of, you know, let me share a video like. So let me know if you can see a humanoid robot on your screen, a small servo-based humanoid robot, a toy. Let me know if you can see the toy, man. I wanted to explain something. Yeah. So I hope everybody can see a humanoid toy kind of thing on the screen, which is built and designed by AI Club. I'll tell you what is the significance of this particular robot. This one has given us a chance to innovate and design very a unique design. This is if I go on Amazon and show you the cost of buying a humanoid robot parts, it will cost you around 2000 like 20,000, 17,000, 15,000 in that area. And we wanted to give students a small kit where students can design at a very low cost, at a very low cost. And with that, they can learn how to, they can learn concepts of control systems in robotics. So how to control servo motors, how to give the robot a stability, what is center of mass, and all these kind of concepts related to mechanical and electrical engineering. So that's why this was our problem statement. But to bring the cost down right from 20,000 to 2,000, we have to do a lot of work. We had to go with the cheapest parts available in the market and miniaturize the entire design. So to miniaturize the entire design, as you can see, this is built on servo motors which can bear a weight of 9 grams. That's it. So the entire body material we have to choose, which should be a weightless material, so that these 9 grams servo motor can bear it. So these servo motors are available online. These are mainly used for aero modeling, where you build a toy aeroplanes, and these servo motors are also available in many toys. So we have to utilize those servo motors to bring the cost down, and hence we had a huge problem of solving the weight distribution, because big servo motors anyway, they will bear a weight of around 12 kgs, but when it comes to small servo motors, they only like weigh around 9 grams of weight. They only take only 9 grams of weight. So 9 grams of weight, we have to make sure every part does not exceed 9 grams of weight in terms of tangential weight distribution. All those things we have to consider while designing this robot. So I guess this is some project I just wanted to share with you guys, and show you how robots will look like. Just give me. So this is the design of the NN COVID rover. This is the first iteration of the NN COVID rover, which I'm going to show you shortly how it looked like. And the first thing the COVID, I'll tell you the story about COVID rover to discuss about different parts, different components we have used in that rover. So it is very simple, guys. We had a small problem statement and we needed to solve it. So how to solve it? We thought about it for a second, and we understood what this robot has to do. So first thing, what this robot has to do is it has to go to go inside a COVID center, and it has to deliver a medicine to the patients, because the doctors who are present, if they are going again and again, it's a waste of money it's a waste of money we spend on PPE kits. And every time the doctor wears a PPE kit, he has to come out and they burn the kit. At the peak times, this is what was happening inside every hospital. And each kit was costing 3,000 rupees. And it's a waste of government money, taxpayers' money. So we wanted to build a solution where for every small reason, doctor doesn't or nurse doesn't have to go inside the isolation ward. So we can send a robot which is highly reusable after sanitization. And This robot will deliver food, medicines, and also doctors can talk to them online through the mobile which is present on the robot. This was the requirement given to us. So now, what all we can do? The first robot we built will look like used to look like this, and this robot should have 6 wheels to take the load of 30-40 kilos of food, medicine, whatever the payload is. So we had the requirement of 30-40 kilos. So we went to select the types of motors. So now selection of the type of motor is very important whenever we are designing a rover kind of robots. So there are different types of motors. We have brushless motors, we have PMDC, permanent magnet DC motors, and we have brushless DC motors, BLDC motors. And in the DC motors, we have another type which is like servo motors or stepper motors. So these are also work on DC power. Excuse me. These motors will also work on DC power, but the only difference is they are position controlled. So we can control the position of the robot, but those motors, servo motors, are used in the application. Excuse me, guys. In the applications like humanoids and industrial robotics, industrial robotic arms, and all those kind of robots, where we need position of that particular arm is very important while assembling and everything. But these kind of robots need a high torque and performance, durability, and also low power consumption. So we went for DC geared motor, 12 volt. We selected that, and we wanted the RPM to be really low so that we don't hit anybody. So there comes the mechanical part of it. Since we are discussing the design, I'm just going to talk about the motors and what are the mechanical components of it. Now, the material. What kind of material we can choose to build a robot? So it depends again. So if you are really planning to build something that roams outside, outdoors, you can always go for material like chrome moly, like alloys, or you can go for mild steel, MS. MS would be really heavy, but if you have the motors very like Viper motors, or motors which are capable of carrying heavy load, and you need a cheap material or easy to fabricate material, MS is a good option. But SS is always there, where stainless steel is also used to build some robots, but mostly stainless steel. Operating with stainless steel is a little hard, except you are having a good amount of facility to operate on stainless steel. Otherwise, the best option, if you just get rid of all those things, if you are able to get your hands on aluminum, that is a very good option to build any robot. So a good grade aluminum will help you build a weightless chassis, and you can accommodate, you can fabricate in any which way you want, and also you can accommodate different types of parts and different types of electronics into it and motors very easily. And even the hand drill, and you can work on aluminum inside. You don't need a workshop to work on aluminum. You can utilize aluminum. You can take the aluminum and you can build something in your own house, like we did during the time of COVID. We didn't have any workshop. We used aluminum only at that time. So it is a very good option to build robots even for outdoors. Now, if you are planning to build robots which can move indoors, or for educational purposes and things like that, I would always suggest you to go for something like plastic. If you're building for kids or something, plastic is a very good option. And if you're going to concentrate on aesthetics, now there was a video which went viral about Mitra, a robot which was like deployed in the hospitals, like Apollo has one. It was developed by a company in Bangalore, and that is also very similar, guys. Like, it's similar to what we have developed in rover, but the only difference is it stands and it has some sort of functionalities with artificial intelligence and to detect faces and also book an appointment. It's a software come hardware application, but here it's a complete hardware thing where we are utilizing IoT to control it. So this robot body which we have chosen is acrylic. Since we had a requirement of sanitizing it, if we would have gone for pure metal. Sanitizing a pure metal would be easy, but again, we don't want to hit any patient, so it has to be aesthetically good, and also it has to be weightless and also appealing, good looking. So we went for acrylic, where we can sanitize easily using you know uh, sanitizing sprays once it goes into the hospital and comes out. So this is about material and motors. Now let's talk about let's go back to our presentation. So now talking about electronics, we have certain things like uh, they're very huge. Electronics is a huge part, plays a huge part in developing robots. So basically, we have mechanical part where we build the physical structure of the robot, and we design the entire load calculations, what it has to do, and what is the purpose of the robot. Based on that, we'll select the material and we do all those things. But when it comes to electronics, we have a very wide variety and wide range of things that are available in the market. So if we are going for these kind of electronics, we need to choose you know the we need to choose the correct correct type of chips that are available in the market. So Arduinos and every other chip that is available in the market are for hobby grade. So if you are trying to build something for the industry, I would never advise you to use something like like Arduino or the Raspberry Pis or whatever the other available things in the market. So we should always go for industry standard chips, and we should always go for industry standard electronics. Like we have a couple of boards from Intel. We have a couple of boards for from different other vendors that are available, who are key suppliers from Qualcomm. Also, we have development boards. But it's just that they are not open source. You need a license to work on those kind of devices. Since this is open source, it is very since we are concentrating on faculty here, it is very easy to get your hands on these kind of open source devices, and students can get a gist of what they are doing. Now, electronics, uh, let me take an example of that robot itself, which we built for COVID. So electronics, how do we choose this electronics? Again, we have to get back to requirement. What was our requirement? Our requirement was to control the robot from outside and send the robot into a chamber, like into an isolation ward. So what do we need here? We need a wireless connection. So we need to think of what are the types of wireless protocols available, which one is very feasible. So we thought of multiple things, and we came up with only one thing, which is Wi-Fi. Because RF, if we would have used radio frequency, the person has to continuously follow the robot or continuously, uh, check the range of RF is very limited. Now drones also are there, but it was 2 kilometers and 5 kilometers range. But we wanted something very robust and also which is totally capable of giving us a feasibility of the control, the complete command over the robot in terms of video and also in terms of control. So there is only one option. We don't have Bluetooth. We cannot use that because streaming video on Bluetooth is very hard, and Bluetooth has 10 meters range. RF is there. Radio frequency is there. With multi-frequency, we can control around 2 kilometers or something. But still, we have to follow the robot around, and we have to check it, and the person has to be there. What if the doctor wants to sit at home and control the robot and see and attend his patient? So we thought we thought of a technology that is really, IoT based technology. IoT is something which we are hearing these days, Internet of Things. And if we are talking about Internet of Things, these days it is creating a lot of buzz uh, because of the small sensors that are available in the market, and also these sensors, the capability of these sensors to be able to connect to Internet. So we utilized that technology here in our robots to connect the microcontrollers or the motors or the actions or the camera on the robot to the internet. So once it is connected to the internet, I can access that internet from anywhere in the world, right? So I can access the internet from anywhere in the world, and hence I can control the robot from anywhere in the world. Imagine being able to sit at your home. Let's just imagine if you want to build a if you are away from your home for for 1 month and there is no cleaning, nothing. You're coming back to your home and you want the room to be clean, like you are cleaning again from the start. Like, imagine building a robot that you can monitor with a camera if somebody is entering your home and also cleaning your floor, that cleans your floor and everything. So for this kind of applications, IoT comes into picture. So the same thing we also utilized in our NN COVID rover. We used a controller which has Wi-Fi in it. We have different types of controllers which gives a provision of Wi-Fi. One such controller is Node MCU, which has a ESP8266 chip on it. And we have different other things which are a little industry grade, which is ESP32 is a little bit of industry grade. We used ESP32 in our robot. It also has touch sensors and stuff, so we wanted to use that. So, and search protection, all these things make the chip industry grade. So while choosing the chip, we need to consider if the chip is really, really reliable or not. There are like certain things we need to check before buying anything to build a robot. So now our requirement is to find a chip that has Wi-Fi, right? So there are hundreds of chips that are there, which has Wi-Fi. How will we choose which one we want to build a robot with? It is really hard the decision to make. So if we want to make this right decision, what we have to do is we have to just think how easily we can program it. The first thing, how open source the application is. We don't want to spend thousands of rupees building a prototype on the license, right? So what if something is available open source? We need to look around. So there are a lot of things available open source: Raspberry Pi, Node MCU, ESP32, BeagleBone, Intel Edison. All these boards are available for open source. But you know, if you really are comfortable with Python, go for Raspberry Pi. If you're really comfortable with C++, go for ESP32. And on the other hand, if you're really comfortable with embedded C, PLC, you have to go for the AVR control boards that are available in the market, which has inbuilt Wi-Fi in them. And that gives you even more industrial standards. So all you have to do is the packaging, the right packaging of these electronics is also very important. So electronics, we once you chose your controller, let's say for us it was really easy to at that time we needed a robust controller, and also we needed an open source time because we cannot spend money on the license. So we went for ESP32. ESP32 gave us the capability of Wi-Fi and also Bluetooth for getting the connection to the mobile app. And once it gets connected to the Wi-Fi, then we will just disconnect the Bluetooth and the communication happens over Wi-Fi. So we wanted both. So the ESP32 provided us with both the capabilities. So we went for that. And also after getting that chip, after deciding that chip, are we done? Like, are we done with electronics? No, because there is a lot more than just a chip, right? Chip's job, microcontroller's job is just to, hold a program, hold a code inside it, and then just give out the instructions to the motors. So this microcontroller will work on only 5 volts power. But our robot is a huge robot. It's a very big robot, which I'll be showing you in a very short time. So it's a very, very, very big robot, and it operates on 24 volts, and the motors are very huge. So this small chip which works on 5 volts cannot provide power to that big amount, right? No, it's really not possible. So we need a mediator electronics. Like we need control systems like we need a lot of control system in between our controller and our motors, our actuators, our end devices. So what is that control system? These control systems are basically relays or drivers that drive the motors, of these things. Now, for example, if we are building a humanoid kind of robot, we go for motor drivers, which are servo drivers or stepper drivers, which gives us the capability of converting the analog signal or digital signal coming from the electronics to a more sophisticated or a more proper control, a meaningful control that can distribute the power based on the algorithm written on the controller. Now, for these kind of rovers, it is really important to have a robust solid state drives or a robust mid systems which can operate for years and years, which are reliable for years and years. So if we are going for relays, relays are very available in the market at very example of relays I'll tell you before telling about relays. You see, in our automobiles, day-to-day life, we switch on self-start, right? If we self-start, what happens is there is a motor that runs and starts the engine, correct? So the motor earlier it was just a motor. Now a lot of electronics is going into automobiles, and also when we think about you know these electronics that go, that there comes our relays. So whenever we self start, a relay will allow the power to pass through the motor. If we cannot self start is not just a button you press and then power just go to the motor. No, there is a relay in between to cut and to start, because the motor, the self motor will give a lot of trouble to our entire engine chassis. There is even trouble of getting shock and stuff. So we need a middle device to control the power correctly. Self motor works on 12 volt, and we have batteries on in certain cars for 24 volts, 36 volts also. But so that relay will allow only 24 volts to pass. We have certain electronics to do that also in the automobiles nowadays. The same problem, same algorithm, same technique applies here on the robots as well. Okay. So that's where these are different types of electronics that are available in the market to design any kind of robots. Okay, so that is about electronics, guys. Don't worry, like if I'm going too fast, I will be stopping while I'm showing the kids. Since this is all introduction to the first 40 minutes or the half time, I will be going through the theory, and then I'll show you all the props that I have bought myself, and also I'll write a small piece of code to show you a robot. So now comes the fabrication part. Like after design, we have already discussed about different fabrications, techniques. Like we haven't discussed the techniques, but we have discussed about different materials that we can use to build a robot. So 3D printing is one such thing that nowadays we are using to prototype. So any robot, before building, we have to go through multiple iterations. So if we are building a robot, it is something we are doing for the first time. It is something novel. It is something that has never been done. But if you are copying something from the internet, well and good, you can find the design. You can just go to a fabricator, given the design, he'll give you like a proper manufactured robot where you can assemble with the electronics and motors and stuff. But if you are building a new kind of robot, you definitely need a 3D printer, or you need multiple iterations, or you need cardboard modeling or things like that. So 3D printing allows us to eliminate that cardboard modeling and everything and directly jump into the real-time parts as in using plastics. So there are different types of materials in 3D printing. Even metal 3D printing is there nowadays. Even in civil engineering, 3D printing is being used to construct home. So that's how the 3D printing has evolved over the period of time. And we mostly in robotics, we use 3D printing to develop robots. Now here we also have a robot here which was developed using 3D printing. So fabrication goes like this, where if you want to design a robot, you go and choose the material, right material for your bot. Based on the design, you start joining using different techniques like welding or CNC cuts for complex designs, or if you want additive manufacturing, you can go always choose 3D printing. So that is about fabrication. Now coming to the programming part, guys. Right? So programming the robot is very it's a very essential part where a lot of people think it is like it is not the job of mechanical engineers, or it is not the job of other departments. It is the job of computer science people only. No, I guess it is really important to think about the program at the start designing phase itself, because there are a lot of things we need to cover when it comes to programming. If we don't have the right hardware and programming synchronization, the development of the robot will go in an unpredicted way. Because now let's see, if I want to build a robot that, let me turn on the video here. Can you hold? Can you hold this? Can you see my face? Hello?
Yes, sir.
Can you see the robot in my hand?
Yes, sir.
Okay, thank you. So this is a small project built by any student here in Narayana Engineering College. So as you can see, the orientation of the design is like this. You see this motors on the sides. This is called differential mechanism. So differential mechanism is like no, it's not like our cars. It's not like our regular cars. So if you just look at a regular car, we have a steering, any type of steering like Pitman arm or any other type of steering, which gives us ability to turn the front wheels. But robots or rovers are not like that. Now, when it comes to robots, we need to be very clear and specific about the maneuver of the robot. So a robot can not move like your car, like front and back and forth. It has to perform certain actions, like on the spot, it has to move 360 degrees, or on the spot, it has to go around. So for that purpose, we use differential mechanism in most of the kind of robots, even in the staircase type robot, or even, the latest robot which we have sent on the moon, which is, what is the name of the robot which we sent on the moon? During Chandrayaan. So that robot also is oriented in the same way, where we have control systems parallelly for these two motors and parallelly for these two motors. So these two motors are connected in parallel connection. Parallel connection is nothing but positive of one motor is connected to the positive of the second motor in the same line, and vice versa for the negative also. So once you rotate one wheel, you see the second wheel also rotates. So because there should be equal power distribution, hence allowing the equal load distribution. That's why when the robot moves forward, we have to make sure that it moves in the straight line. When it moves in the left direction, it has to move cut exact left, because the controls are very important for us. Thank you, sir. You can stop the video. I hope you understood what I'm talking about, the robot orientation here. So the orientation is basically about all about the placement of the motor. So you can go for a 6-wheel drive, you can go for 4-wheel drive, 8-wheel drive, or even you can have multiple types of things. Now, if we take about different other types of robots, let me show you one more kind of robot which is really innovative. If I show you one more kind of robot, which is I hope you can see my video, which is this one. So you see this. This is a spider robot, and this robot has 1, 2, 3, 4, 5, 6-wheeled, 6-legged spider robot. So if the 6-legged spider robot is like this, you see this. It is not rotating. The legs are there. So these motors are servo motors here. So here we have servo motors, and unlike you see, if you see this motor here, you have 2 wires here, positive and negative. But when it comes to servo motor, we have 3 wires for each motor, positive, negative, and control signal. Signal will define you what is the position of the motor, because this can rotate, move forward, backward, levers, left, right. But when it comes to this kind of spider robot, what happens is, we cannot just make it roll like that. There is no point of designing a spider robot, right? So if we really want to, control it properly, we need to give the exact position where this each and every leg is standing. so that it has to move forward, move backward, forward, move backward like this. So I'll show you shortly how to program this these robots. But understand the gist of it, guys. The thing is, what I'm trying to say is, these robots, depending on the the programming varies. So depending on the motor, the programming varies. Depending on the orientation, the programming varies. Now, my friend, can you show that robot? So that is a COVID rover's body. That is a COVID rover's chassis. It has sensors, it has motors, but the motors are really, really big. Okay, so those motors are so big that we need to use highly industry grade relays to control those motors, and it operates on you know 24-volt battery on top of it. It is mounted. So that's it. So that is about programming. So based on the orientation, hardware and programming are always independent. Like sorry, always dependent. We cannot assume that programming we can do it later. Let's just first design the robot and then just go ahead. So it's not like that. When we are designing a robot, we need to consider all those things. So that is the introduction about that is a complete introduction so far about everything about the components. Now I will take you a complete video through each and every component we have here, and small components which we can utilize designing a robot, like our own COVID rover, or we can also or the components which are needed to design a humanoid also. So before that, let's take a short demo of what we can do with this spider robot. Can you come here? Just keep this aside. To show this, you can remove this for some time. Guys on the call, I'll just stop for 30-20 seconds to ask if I was clear so far. Ma'am, can you mute if somebody wants to talk to me? Audio wise, quality wise, like delivery, speed, everything.
Everything is okay. We are using here only servo motor, and any other motor we can use
for spider one.
Yeah.
Yeah, we can definitely use 360 servo motors. Also different types are there. 360-degree servo motor is there. We have servo motors which are industry grade, like which are very huge, that are being used in automotive fabrication area, where you assemble different types of motors. And also we can use DC motors with encoders. Okay, so DC motors with encoders in can you bring that Iantra robot? Iantra robot. No, it is there, sir. Yeah. So very good question, ma'am. Actually, for control, for position control, servo motors are very, not this one, sir. Iantra. It is in that room. Iantra robot, box with this. So, like servo motors are very small in size, and if you are controlling the position of those motors, you can design robots like these only. Okay. But if you want to design a big robot, which is huge in size, and also you want position control, definitely you need to go for DC motors, which are having heavy gears and which can give you heavy torque. So the question comes here: how do I control continuously rotating motor? How do I control its position? Iantra, round. So basically what happens is, every motor on the back side, every encoder enabled motor on the back side of the motor, it has a fan-like structure, just like this one. So it has a fan-like structure just like this one. So come closer. Can you show this one?
Yes, sir.
So it has a fan-like structure like this one, and it has an encoder chip on top of it. This encoder, what it will do is, each time the fan moves, encoder counts the number of revolutions. Based on the number of revolutions we have in the program, we will have to write each revolution one step we will count, and based on that, where the robot is moving with the we can calculate, and we can define the position for DC motors also. So we always don't need servo motors. We can also use DC motors, but I would say the programming is a little difficult. when compared to this one. Okay. So that is something you can do.
Okay, thank you, sir.
Okay. Okay. So I'll move on. We can have the questions later again. I'll move on with the different parts. Okay, sure. So I'm done with the screen sharing, guys. I don't want to share the screen anymore. Let's do a lot of video thing. I'll just close the presentation. So by the way, that presentation was meant to be given to the students, but I just wanted to use it. I hope you understood what I was talking mostly. Okay, so uh, let me just let me just bring couple of sensors. Give me 2 minutes time. Yeah. So we have different types of parts, guys. So to build any robot, we need a microcontroller. As you can see, let me just fill the camera. I hope you can see this robot now. So
yes,
you see this is a microcontroller here, and the chip which we are using here is Arduino Uno. So this is a small robot that moves forward, backward, reverse, left and right, and you have a radio module, a radar module that detects if somebody is in front of it, and somebody is there, it will move automatically, so something like that. So basically any kind of robot, radar or obstacle avoiding, line following, everything is same pretty much, but only the sensors changes. So I'll show you what are the sensors also. So this is a microcontroller Arduino, and you have a display here to display how much distance is there in front of the robot. Maybe you have different types of motors here. So if I just turn around, you have the motors around here. So you see this is a 2-motor drive, and here there are dummy wheels. So this is a basic structure which you can utilize to teach students about major robots. Now let us directly jump from small robot to our biggest robot. So as you can see, this is your NN COVID rover, and the robot here. The robot here utilizes this particular Viper motor. As you can see, this is a Viper motor, and you see the chain drive going to the shaft, and we have big wheels here. Always if you are designing a robot which for industrial use or for some sort of use, you should never connect the wheel directly to the motor. It is always good to have some sort of chain drive or gear drive where the load is directly not associated with the motor. Because again, if the robot is running and if you try to stop it, or if it stops, if you try to stop the running wheel, the motor burns out. So it is not never advised to have something like a direct motor shaft and a wheel attached. So now you see here, this is what I was talking about. These are the relays. These are the industry grade relays which are available in the market, where each relay is controlling one relay for left motor forward, one relay for left motor backward, one relay for left motor right motor forward, right motor backward. So one relay for entire operation on and off. And there is a controller, Wi-Fi based controller ESP32 inside this one, which can connect to our Bluetooth first, and then also connect to your Wi-Fi. So once it connects to Wi-Fi, everything happens on the over the Wi-Fi network itself. Now coming to the sensors part here, since we are dealing with patients in the hospitals, we don't want this robot to go and hit anybody. So we are using ultrasonic sensors. So that will give a feedback to our microcontroller that if somebody is standing in front of it. Each sensor works in its own unique way. Ultrasonic sensors theory is like, it is very simple. So ultrasonic sensors basically work on a principle of ultrasound. There are two beacons over here. Both of them shoot a trigger wave. Ultrasonic wave is triggered out of the sensor, and if somebody stands in front of it, the wave. Okay, sorry, I'm showing the back camera. So if somebody stands in front of the sensor, like if I'm keeping the hand, the waves will hit my hand and return back. So immediately the sensor will also see what is returning and it will catch that input. So once it catches that input, how much time it has taken to travel, that ultrasonic wave has taken to travel from there and return back. Based on that, we will decide. We will decide at what distance the object is. So that is one sensor, guys. Now I'll show you the controller in detail. You see this? We have a controller with us here. So this is a microcontroller, just like Arduino board. Arduino controls different types of devices from GPIO pins. So there will be a lot of pins here, you know, 1, 2, 3, 4, 5, 6 like this. Each pin is associated with an output or input device. Output devices can be your motors, actuators, pneumatic pistons, anything. Okay, anything you wish to control the robot with. Okay, and also input is basically given from the sensors, just like the sensor which we just discussed about ultrasonic sensor. Okay, now coming to the part where we have motors. So there are a lot of motors which are available, like in the market now. These are the toy kind of motors which are very good for learning. They are very low power and these can operate at 9 volts also. But as you can see, in the industry grade we use wiper motors because they are very long lasting. These motors are very delicate and only for the learning purpose we can use it. Okay, now coming to the servo motor, this is one of the type of servo motor that we will be using for a lot of works. Okay, so I will be showing the demo on the servo motor very shortly. So that's it, guys. These are the couple of components, and for connecting, we have breadboards and we have different kinds of wheels are also available in the market for educational purpose. Now, box to antenna. We need to have VDRs. Yeah, you see this? This is a light dependent resistor. Okay, the resistance of this particular sensor is this is not a sensor. This is a resistor actually. But a combination of this resistor and a normal resistor will make you a sensor using voltage division. So it is a whole together another topic, how to build sensors. So any sensor, why I'm telling you this, because any sensor is directly will not give a value. Like if you want to measure temperature using a temperature sensor, if you just connect it and write a code to measure temperature, you will not get it. Any sensor will give you a value of voltage equivalent. Okay, so it will give you an equivalent value of the like voltage or current. Based on that, we need to calculate that. Based on the threshold value, we need to calculate how much the sensor value will be. So you can search for LDRs where you can find different types of you can search for LDRs and where you can find how the sensor is being made. It is a more simple form of building a sensor using light dependent resistor. Okay, so there are many uses of LDR actually. Out of which you can design projects like controlling fans and lights of your home whenever the sun comes up and lights go off, things like that. So you see this?
Yes, sir.
This was not functional. I just wanted to give you a demo of this one. This was not functional before, but I wrote a small piece of program. Now I hope you can see my screen, right? So let's go back. In this short time, I also wanted to cover a little bit of practical. Now that we have 20 minutes of time, let's do a bit of coding now. Okay, I hope you can see the video, right? So I want to make it, this is dancing very fast. Let's say I just wanted to, make it really slow. I have changed a couple of values and now see how the output changes. You see that? Now again, I will change the values. and it should dance again. So I'll just tell you what is happening here. This is the IDE which I'm seeing on, which I'm sharing the screen. We can write the code for servo motors. Servo motors are basically DC motors with position control, as I told you. So it will give the power based on the power time. How much time it is taking, we will we will be able to deliver the position feedback. So based on the position feedback we can write. So here the servo library is already available. I'm utilizing that servo library. Based on that library I'm using it. So I have attached pin number 2 and 3 of Arduino for controlling this particular robot. So what if I change? Now you see these two things moving, right? So what if I change from 2.3 to 2.5, okay, and try to upload the same code? You see that one is moving. See the motion. And if I want to move another motor, I'll change the value from 2 to 8. I hope you can see my screen. You see that? What is happening? So it is drawing an arc. Okay, if I change the value of one motor here, I'll explain how I'm changing the value and what is happening here in the for loop. Video also, no? So can you see the difference? I hope you can see the video, guys. Okay. So anyways, let me stop it. Let me stop it and explain the code. Video. Video చూపించాలా? Last video. So we can share that video if you have any group. I'll send you. We can share that video with the group. The phone is. Okay, so now coming back to what is happening here. First, we take a variable called position. Initially, the position is 0, and each servo motor is capable of moving from 0 to 180 degrees. Now, you can see in this video I was showing, right? So each servo motor is capable of moving 0 to 180 degrees. So 0 degrees and 180 degrees, its movement is controllable here from this particular piece of code. So this particular piece of code will give you 0 to 180 degrees. Now, if you don't want this 180 degree turn, if you just want this to move tap, 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 like it will just move on and off, on and off, on and off. You want this to hit like this. Okay, what you have to do is you have to keep the same thing. And you want to give, like, let's say 30 degrees, and from 30 degrees to 0. Let's see what happens here if I give it like this. Sorry. First, you need to connect the cable, and then you need to click upload. So that 30 degrees is not even like. You see that? If you just want to increase it, it's not. I don't know if you are able to see that robot dancing or not, but it is dancing. Now it is dancing more. Just by tweaking these values, you are able to code it. You are able to do all sorts of amazing things with this robot. But but before coding, we need there is a lot of work that has been done on this robot already. So you have a controller, you have a controller for motors, driver, which we call, and you have a lot of stuff going mechanically here. All these parts are built using 3D printing, and you see all these servo motors are like very sophisticatedly assembled here, and hence finally you are able to easily change the code based on that. You need to know, right, which connection where you are giving number 2, number 3, or whatever it is. Okay, so instead of 8, I'll just upload it again. Now tell me what happens, guys. I'm putting 2 and 3 motors and I'm making it dance. Can you see my video? Yeah. Okay, so with that, I, I'll I'll just stop now, and we have 10 minutes of time to discuss about different other parts like sensors. So now we have different types of sensors. I'll just utilize Google to show you different types of sensors. Okay, so if you go on Amazon, if you're planning to buy and work on different projects, just buy these kind of kits which are available, which will cost you around 500 or 1000 rupees, which will give you a lot of sensors. So in robots, it's not only about robotics. In general, I am telling, if you want to build any project which is related to electronics, or which is related to robotics, IoT, and all these technologies are interconnected, guys. So it's all about sensors and control system, how you are going to utilize the input, and based on that, how you are going to give the output. So sensors are very essential. Now, let me open this in a big screen. So you have, see this, you have a joystick. Joystick is also a kind of sensor where you can utilize this particular thing for controlling the robot, left, right, forward, backward. And you have flame sensor where the robot is moving in a fire extinguishing robot or something like that. Where the fire is there, it will detect and it will move in that direction. If you want to build that kind of robot, you can use flame sensor. And RGB LED. RGB LED is not a sensor, but it is an indicator kind of thing. If somebody is standing in front of it, it will glow a red light. If you don't want any sound kind of thing, you can use these kind of things. Heat sink. Yeah. What is that? Heartbeat sensor. Heartbeat sensor is not utilized in the robot because that doesn't have any heart like this. So heartbeat sensor is utilized for many other purposes like uh, uh, if we are building any project related to medical equipment, we can utilize this one. Light cap, and we have lot of sensors here. If you want to use any sensor based on this, we can use it at temperature and humidity sensor. And there is a buzzer. We also have that buzzer in the COVID rover where it will buzz if somebody is standing in front of it. And I wish I can show you the demo, but unfortunately we don't have charge in that. And uh, so these are the sensors, guys. So these are different types of sensors. Now I guess we have 7 minutes for question answers. I can take video. So okay, let me show you the video of the COVID robot. So guys, you can ask me. Meanwhile, I'm going to show you a video of an COVID robot. You can ask me if you have any questions. Hello. Hello. Guys. Hello. Can you hear me?
Sir.
Okay. Let me just show you that video. Hello.
Hello, sir.
Hello? Hello?
Hello, sir. Hello.
Hello?
So, చెప్పండి సార్.
Oh, no, share చేస్తున్నాను. I'm just sharing a video.
ఓకే ఓకే సార్. ఇది ఏం షేర్ అవ్వలేదు సార్.
మ్యూట్ లో ఉంటే మనం మాట్లాడేది వినబడుతుంది.
ఎవరికైనా డౌట్స్ ఏమన్నా ఉంటే అడగండి. If somebody has any doubt, please ask me. Meanwhile, I'll be sharing a video. It's getting downloaded.
So participants, if you have any doubts, please. Sir is waiting for our interaction.
So this is only 1.5 hour time. Okay.
Hello. Hello, participants. You have any inquiries, please?
Hello, sir. For fabrication, we are using
Yes.
3D printer only, or any other technique is also there?
Yeah, 3D printing is there. Other than 3D printing, we have a lot of other options where we use traditional manufacturing techniques.
Okay.
Okay, traditional manufacturing techniques as in we have stuff like normal welding and CNC cutting, and we design all those things. First thing is we draft our design and then we go to a workshop, and then we build cardboard models or foam models of what we are trying to build, because if we are building a straightforward structure, it is really easy. But if we are building a robot, it has curves, it has a lot of complex structures. And those complex structures, if we really want to build, it is always good to have those kind of prototypes first. And then based on that, we can move ahead if they are good.
Okay.
Why
And
my
in designing
Canada
tool,
is
you are saying
Canada
AutoCAD.
Bahar.
Yeah, AutoCAD and those things are designs.
AutoCAD, CATIA, and SolidWorks.
Yes.
Actually, we are from ENTC branch, and these tools are mostly used in mechanical department. Which one is easy for ENTC students?
Okay, so if you are talking about if it is really hard for you to learn designing and all, like SketchUp is one good option.
Which one?
SketchUp.
Okay.
Okay, SketchUp is very good option to start with. If you really want to go ahead with 3D printing, there are a lot of open source 3D printing options. You don't need to design any robot. So
Okay.
you can simply you can simply take the designs from online from different 3D printing websites where they will give you open source designs about robotic arms, robotic wheels, structures, and everything. So that is one thing you can do.
Means as per our requirement, we can make the design.
Yeah, you can do the changes also in that design.
Can you explain that part?
That part is like, it's not about explaining. It is available in the online. Like I'll show you 1 second.
Okay.
So there is a website called 3dhubs.com, all3dp.com. So these things will give you a lot of designing physical objects. ThingWorks is a very good website. I will ping you in the chat. You can check. They have a vast variety of objects that you can utilize. So basically if you are a non-mechanical background people, then you can use these designs which are already there. Some of them are paid, some of them are not paid. So it is based on that, like how you want to utilize it. Do we have a chart here in the Zoom?
Just wait, sir.
Sir, can you repeat the website once again, sir?
That's what I'm trying to post that website in the chat.
Chat
Do we
option
have?
is not available, it seems.
Oh, okay. I will ask
Directly
sir to
mail
share
us.
it. Yeah, I will ask sir to share it. I have already pinged to sir.
Okay, sir.
ThingWorks is the website, and also there is a 3D. I will tell you there is a easy 3D designing software also for 3D printing. I will tell you that also. I will ping you that also.
Okay, sir. Thank you, sir.
No problem. Any other doubts?
ఆయన ఎప్పుడు ఈ మమ్మల్ని కట్టినీడు 24/7 ఆయన అంటాడు.
ఆ వీడియో కూడా షేర్ చేసేయండి ఇంత ఎంబీ వీడియో రావట్లేదు. అదే మీ ఇంటర్నెట్ వాడుతున్నాను. షేర్ చేయలేదు. Thank you, guys. I'm done with my session. Thank you.
Hello. So participants, do you have any doubts finally? Okay. Very good afternoon to one and all. And very happy to about this session, afternoon section, lab section given by SD Paras sir, Technical Manager IA Club. Sir has provided brief information about how to design, how to develop, how to fabricate robots for various applications. What much of knowledge is required in all disciplines, not only for mechanical. Mechanical concepts are very much required for designing of this structure, frame, and materials, 3D printing, etc. And also electrical concepts are very much required for design specifications for motors, controllers, and also electronic components are very much essential. At the same time, computer knowledge is also very much essential. If you want to design any robot, if you want to develop any robot for any
Hello, sir. Hello.
hello.
Sir, it's not audible. Sir. Now it's audible, sir.
Is it audible?
Now it is audible, sir.
Hello.
It is audible, sir.
మాట్లాడండి సార్ మీరు ఇందాకనే దాంట్లోనే మాట్లాడుతున్నారు
హలో
సార్ మాట్లాడండి సార్
హలో మేడం
సార్ ఈజ్ ఆడిబుల్ సార్
హలో
సార్ చెప్పండి సార్
మేడం
సార్ ఆడిబుల్ సార్ వినిపిస్తుంది ఎస్ సార్ ఇట్ ఈజ్ ఆడిబుల్
ప్లీజ్ రెస్పాండ్ ఎనీ పార్టిసిపెంట్ anyone please respond.
It is audible, sir.
It is audible,
okay.
Sir.
So if anybody want to design, want to develop
not audible
robo for various applications in medical, dental, or manufacturing or services,
not audible well not audible to me
in all engineering disciplines. So in that aspect today's
Sir, can you change, sir? Hello.
Hello, వినబడుతుందా?
ఇప్పుడు వినిపిస్తుంది సార్.
Okay, sorry for the inconvenience. Again, I'm going to conclude the session. Before going to conclude, I really thanks to our Parvas sir. I hope in today's 1.5 hour section, sir has covered detailed components and its assembly. And if you want to design any robo, if you want to develop any robo, if you want to fabricate any robo for various applications, whether it may be manufacturing sector or medical or dental or service or domestic applications, one should have sound knowledge in all engineering disciplines like mechanical, electrical, electronic, and computers. So in that aspect, sir has given a detailed explanation about the components and their specifications and their importance in the development of a robo. I am very much thankful you, sir, for your valuable presentation during this 1.5 hour session. And also, I am very much thankful to all the participants for your active participation. Once again, good afternoon to one and all. Thank you. Thank you so much.
Sir, I want to say something.
Okay.
At first, thanks, Sridhar sir, because he
Thank you very
explained
much, sir.
very nicely. He explained as well as demonstrated the robot, and
Okay, thank you.
and we are interested to take the help from him for our robotic laboratory.
Definitely, madam. Definitely, I will send the details of SAR details, email, phone number, everything to you, madam, because we already established association with Aicte Club past 4 years, and we have developed so many products, and also nearly 1,000+ students have trained under his guidance.
Okay.
I will also send the information to you, madam, about Parvaz sir. Actually, one thing I want to share with you on this occasion, just 3-4 days back, sir suffered with some kidney stone problem.
Okay.
Even though sir joined with us in today, I hope in future also we will continue the similar type of sections in future also. Thank you, madam. Thank you so much for your inquiry. Thank you.
Okay. Thank you, sir. Thank you, sir.
Excellent.